Hi, welcome to the Oxford MAT Livestream. Just an experiment. We're doing a pre-live bit of just chatting. I'm early, I'm bored, people are here. I thought might as well start live streaming. This way at least I can work out any gremlins before we actually start at 5 o'clock. Hi people who are live early, nice to see you. Here's what I want to show you. Dan in chat has just linked to a thing called MAT card flip, which I'm going to play with for a second. I think I know how this works. I've just seen it. Dan just linked it. It's called MAT card flip .versal VERCEL.app, and I think it shows you some of the MAT flashcards and then gets you to pair them up. So this one says prime number, and then we're supposed to find that's not a prime number, that's a right angle triangle. And this one is some sort of log of 1 over f of x thing, which is not cos squared. And I think it's a kind of matching game. Alright, Pythagoras, thanks for thinking of that one. Great, okay. No, that was cos squared, wasn't it? So these are based on the MAT flashcards, and it looks like Dan might have taken the images from the version that we put up as well, or possibly Dan's taken a bunch of screenshots from the MAT flashcards. Oh gosh, that's the sum of an arithmetic progression. It's really small. Primes, finally, there we go. What have I got left? Logarithms and the sum of the terms of an arithmetic sequence. Cool, so there's a little toy. This looks like it's using about 8 of the cards at a time, and there are 60, so I guess every time you reload it, yeah, you get a different selection of cards. If you want to play a matching game with the MAT flashcards, then you can do that. Thank you, Dan, in chat. The cards flip before you can look at them. Yeah, it sort of shows you the cards when it loads. It shows you the cards very briefly, which I don't quite get. I guess if you have an incredible photographic memory, then you get a mild advantage, because you can just load the page, see all of them, and then, oh my goodness, pair them. But I don't know, maybe that's part of the fun. Right, hang on, let's switch. Let's do some switching around. We have not started yet, we're just chatting. We're playing with a web app that Dan's made based on the MAT flashcards. Would love to know how you made this. Hang on a moment, let's turn on chat as well, that sounds like fun. Yeah, we're just chatting. And I've got to remember, the thing is, I've got to remember in 10 minutes, I've got to remember to actually just to start. Someone in chat says, why don't I use Temple OS? You know, it just wasn't installed on my work computer when I got here. You know, I haven't got around to installing my own esoteric operating systems. Why do I use MATLAB? Well, because I was trained on MATLAB and I'm too lazy to learn anything else. I'm trying to do better. I'm trying to learn a second language, Spanish, but also I'm trying to learn a second programming language, Python. So if I learn Python and Spanish, then I think I'll be sort of a better person who isn't just restricted to MATLAB and English. I can write, I guess, Spanish Python code. That's the dream. And JC wants to know about St John's College. He said they don't value the interview as much as other colleges, which is an interesting statement. Interviews are not perfect, and I guess the point that St John's College website might be making there is that they have lots of other information, like your MAT score and things that you say on your UCAS application, and maybe their personal interpretation is that they think that other information is more useful than necessarily everything you learn during an interview. This is why it's difficult when people ask me for weightings. People sometimes ask what's the weighting on interview and MAT scores, and it's really subjective. It's really different from different people, different colleges, different tutors within colleges, and it's a human decision at the end. Why don't we accept STEP or BMO or IMO instead of MAT? Yeah, so for us, we think STEP happens too late in the year. We want to make all of our decisions by January, and we don't really want to make them conditional on STEP because we want to have made pretty much the right number of offers there. I know Imperial and Warwick do this complicated thing where they use different exams at different times. Although I'm not sure that Imperial, does Imperial really accept STEP? I'm going to fact check that, I think. Does Imperial really accept STEP instead of MAT? Not certain, you'd have to ask Imperial. And BMO or IMO, my opinion is that if you can do BMO and IMO questions, then I'd hope you can also do MAT questions too. So not too tough, hopefully. Right, good. Okay, if you've just joined us, we haven't started. I was just bored, so I'm doing a maths live stream because I'm bored. There we go. Herb, you are not late. I am early for a change. You're going to see this is different. This is part of the experimental phase of the live stream. Last week we tried being a reaction channel. This week we're trying to be just chatting, which I understand is an entire category on Twitch. We're not on Twitch. We're on YouTube. I did have to try and explain Twitch to people in the maths department when I started. Is there a significant difference in math score for successful applicants? For successful, so it's filtered down to successful applicants from independent and state schools. I don't have a number in mind, but my impression is probably. And if there is a significant difference, then it's the sort of thing that tutors should be aware of, I guess. Something we look at is much more subtle than state school or independent school. We look at several actual indices when we're trying to sort of contextualize applications. So we might look at lots of things in context. We don't have say a sort of hard threshold for state or independent. That would be a really clumsy way of doing things. Dan tells us that the app that Dan made, which I'm going to show everyone again just briefly, it's based on MAT flashcards, and it shows you all of the cards. Made it in a tutoring session with a student. The code is on GitHub if you want to. That was not the area of a triangle, that was the cosine rule. There we go. Oh, great at the flashcards. There we go. Thank you, Dan. It is made with React.javascript. I'm going to pretend I know what that is, having admitted a minute ago that I only speak MATLAB and English. Right. Hi, Dres. Dres? What am I going to go? Dres, I think I'm going to go with. I'm really sorry if that. Acting like I forgot about Dres. Sorry. It is cool, and it's a matching game. Oh, I clicked on the area one. You're not supposed to do that, right? Where you click on the one you already saw. Oh, I'm doing terribly now. I started so strong. Stretches, translations, looking for orthogonal lines. Area of a triangle. Yes! Oh, I got my triangle snap. If you want to play this, Dan has built it and put it at matcardflip.versal.app. I'm going to take that link and make it huge. Let's take that link and make it huge. Dan, look at this promo you're going. Well, that's not gone well. There you go. You make something cool. You get your URL on the live stream. Them's the rules. Hi, Samira. It is a good looking website. Is it the? Hang on a mo. I've just realised. Is it the? Let's take a screenshot of that patch. Feed it back into Paint. Open Paint. Drop in the screenshot. Color picker tool. Edit colors. 03370. Yep, that's Oxford blue. It's perfect color match for Oxford blue. Good job, Dan. Right, okay, let's put the branding on it as well. That's pretty good. Bonjour, Anonymous. Good. If you're interviewed, you usually get asked about 2 questions per interview, but the questions are kind of multi-stage. We might do several different things along the way. I generally ask a follow-up question within my question on the same topic if I want to. So the interview lasts for about 25 minutes, and it's maybe the best way of thinking about it. Good. Okay, what are we doing? We are chatting, and we haven't started yet. And Dan has made this. Let's tidy this up a little bit. I think it's better if I don't put the. Oh, maybe I have to because it's not a www. I'm gonna tidy it a little bit at least. Dan has made. Now it's gonna have a red squiggle. There we go. There you go. Good job, Dan. If I got SS in STEP, says an anonymous person in chat, so those are the top grades in STEP, a very hard test, but 2 in GCSE maths, it seems unlikely already. So you're asking me to condition on something that's got very low probability, which makes me nervous. Probably something happened in GCSE maths. No A-level maths or equivalent. How would other people react? Well, I've given that away, I suppose. Let's do a social experiment. Someone do it. And for the STEP questions. Right, okay, yeah, I think my reaction is, this is something's going on there. Hi to QZ. I feel really sorry about Dres. I mispronounced Dres's name because I pronounced it about 3 ways, and then I just feel bad. Right, okay, if you're joining us, we're just chatting. We haven't started yet, don't worry, you haven't missed any maths. Dan has made a thing. Thank you, Dan. It's a kind of thing based on the flashcards. I want to quickly promote something I did because we haven't started yet, so I'm allowed to do shameless cross promotion. The thing I made is a video on the main channel. This is our Oxford Mathematics Plus, our second channel. Oxford Mathematics is our main channel, and I made a video for kind of everyone about the mathematics of shrinkflation. It's about the way that things scale and the surprising way that 3D scaling works. I've got a thing that I can show you that I made as a prop for the main channel video, which looks like this. It's two cubes. One of them is slightly smaller than the other one, but only a little bit smaller. It's only 20% smaller by side length, so that's 80% of the full side length. So this one looks only a little bit smaller. Gosh, there's a lot of camera effects there where they look really the same size if I put one of them close to the camera. But this one's smaller. The sides are 80% as long, and its volume is half the volume of the large one. If they were made of solid metal, then this one would be twice as heavy as this one, which is weird because it doesn't look twice as big, and this one doesn't look half the size. It looks about the same size. And the idea of the video that we've got on the main channel is that producers could maybe use this to trick you by making something that used to be this large. It looks about the same. It's actually half the size, which is quite a big reduction. We made that kind of for everyone. I put it on the main channel. I would really like people to see it, I guess, having made it for, in some sense, everybody. So if you saw that on the main channel, it would mean a lot to me if you either A, showed it to someone else, or B, left a comment on that saying, hey, I know that guy. I just think that would be fun. Right, good. That was IRL, yeah, and a bit of a jump scare. Sorry. There is a code on GitHub. What did I miss? Pre-live. That's right, we're pre-live. Matt Test Centre, now list your school and everything is sorted. Thank you for the advice for last week. Yes! I never get closure. Closure on helping someone, and then they came back and said that I helped. Brilliant. Right, pre-live, absolutely been worth it. I don't know how to switch to the actual live stream. How do people normally do this? Like other shows that you watch, do they just like start? Am I supposed to go back to the hold screen? I'm going to go back to the hold screen, I think. That way also I can, if I want to, edit off the pre-live bit. We're going to pretend I didn't do that. Burrito Man wants to ask a question that's loosely related to mathematics and possibly loosely related to burritos. There's nothing to stop you, but I'm about to go live with the actual thing. I have to do a little dance and then start. Okay, I've been learning this. I've realised that TikTok's only actually got one dance, so I could just learn that one dance and then I'd fit right in on TikTok. I was a question about why Cambridge doesn't have this. That's a bit unfair, right? Just because I'm doing a cool thing, it doesn't mean we get to dunk on Cambridge for not immediately copying me. But maybe you could let them know. But we could definitely let them know. I think I'm planning to apply to Oxford instead because Oxford seems cool. Right, good. I will let everyone know. Right, okay, we're going to switch to live soon, and then we're going to go live because it's 5, and we're live at 5. I think this makes sense. Little dance because we're talking to you, and then okay, and then switch. Going live soon. This makes perfect sense in my head. I need to delete the sign that says we haven't started yet. Okay, for real. Hello and welcome to another episode of the Oxford MAT Livestream. My name's James and today we're talking about the 2009 and 2010 papers. Hi to people in chat as well. I'm just going to switch on chat on screen while we get started here. The plan is to go through questions from 2009 for the first hour and then at 6 o'clock, short breaking, then talk about questions from 2010. Burrito Man would like to know if I were a burrito, ratio of rice to beef. I am all about the carbs. I just really do like carbs. Yeah, I think I might be like 90% rice, which doesn't actually sound like a very nice burrito. So I think that's kind of dissing myself. On that topic, how do I apply to take the MAT? Says someone in chat, which is a much more serious question. On the Oxford website for Matt, it says to check back. So you can't apply yet, but your test centre or your school or college or wherever you're planning to take the MAT can currently register as a place that does the MAT. So that's what's currently happening, which means that you don't currently do a thing, they currently do a thing. I hope there's a link from the MAT page to the thing for your test centre to do. It's not hard to find. It's ox.ac.uk/tests. That's plural, TESTS. So there's a place to go to sign for your test centre to sign up. But that's what should be happening right now in August as we get ready to do the MAT. Right, time to work. So I think first we'll do a quick poll for how was your day. I'm having a bit of a 5-star day. I just went for a walk around the Oxford, what are they called? The park? I've completely forgotten the word for park. That's a pretty bad start. I'm having a 5-star day. It's nice and sunny outside, which is unusual. Okay. Oh, look at that distribution. It's like a little staircase. There we go. Good. Occasionally it goes bimodal, which I also like. Always watching out for people who vote 1 star or 2 stars. You've turned up. You're going to do some maths. Someone would like me to review their personal statement in chat. Now, there isn't space for them to paste their personal statement, so they've put a summary. They've said their personal statement goes: 1, I like maths. 2, I've done some maths. 3, I've read some maths. 4, I've done some more maths and hard problems ETC. 5, I'm a human. But all in terms of what I've done, so 20% humanity. Okay. In terms of what I've done, is that enough to stop me getting deslated? Yes, sounds fine to me. Sounds fine. I can't think of anybody I've deselected based on their personal statement. I think it'd be really hard to write a personal statement that got you deselected, for Oxford Maths at least. Most of the personal statements I read look like that, which is fine. Right, okay. Someone in chat's very, very keen on computer science. I think they're probably going to study maths and computer science at university. Good, okay. Right, this is the vote for how was your day. Let's see how that's going. Oh, 3.9, that's a little bit lower than normal. We've got several viewers live. And people are asking questions in chat. So I sort of let 4 and 5 draw, which feels like a good place to be. And then switch back to live chat. 5 is just 1, good. Right, let's stop. 5's ahead. Stop the voting. What would happen if you leave your PS blank, personal statement blank? I think UCAS probably flags it. Probably asks you to go back and write a personal statement. I'm not sure. I've never tried. If we received it with a blank personal statement, we'd probably think you'd forgotten to do it. On the open day, one of the tutors implied they ignored your personal statement. Yeah, sometimes they've got good information in there. But if it's irrelevant stuff, then I'm not necessarily going to read all of your karate achievements. I might skip that bit. American student, can you reach out to close test centre? Go for it. Give it a go. It's not too late to register more test centres. So if there's anything nearby, it's not too late for them to try and register as a test centre. And it's GCSE results day. Does that affect anyone in chat? If you've just got your GCSE results, then congratulations, I guess, on your GCSEs. And the question about international students. We've noticed sometimes international students is such a large group, right? It's such a complicated large group. We don't have a sort of one-size-fits-all policy for international students. Good. Maths more important than personal statement because maths an actual maths test. What happens if you as a uni get a personal statement with a UCAS similarity detection warning? I've never actually seen one of those. I'm not sure they get passed to me in the maths department. I don't know if somebody somewhere gets a notification. Please don't plagiarise your personal statement. Hooray! Herb says it's Pluto Emotion Day, which I wasn't aware was like a annual holiday, but you know, I guess it does make me sad, I suppose. But I already voted 5 stars. Hartford said that they would barely talk about your personal statement. I would barely talk about your personal statement. I don't think I've ever asked anybody about their personal statement in an interview. Yep, you can have that recorded. I've interviewed for maths several times and I've never asked anybody about their personal statement. I've done maths questions instead. If I need to see what's in their personal statement, I have a copy of it and I can go and read it. I know some people try and talk about personal statements to try and make people feel more comfortable, but I've never really tried that. Tara's been to Nando's. Oh my goodness, loads of people have missed their grades. A-levels have been a bit tricksy this week. Right, good. Okay, we're going to do some maths. I think I'm going to pick a first question while we vote on questions. There's a vote going in chat right now, but I'm going to pick first. I think I'm going to pick this one because it's in the thumbnail, and it's question 1J, which feels like a good one to try. I'm going to turn off while we're voting, I'm going to switch that off so we can see the question. So this is about solving this equation, or I guess looking for positive integers that satisfy this equation. And the thing to spot is that this left-hand side is not as bad as it could be. So what have we got? We've got an x cubed, we've got something like 8y cubed, which makes me think, look, so there's this pattern, x cubed, x squared y, xy squared, y cubed, which makes me think that's what I would get if I multiplied out something cubed. Let's try and make that precise. That would be like an x getting cubed, and over here this would be like a 2y getting cubed. And if I actually worked that out, then there would be some cross terms as well from some other things, as well as x cubed and 2y or cubed. There'll be some things in the middle, but I think it actually works out because this would be 3x squared 2y plus 3x 2y squared plus 2y cubed. So I think it all works out because that really is 12xy squared, and that really is 6x squared y. So this is exactly the thing on the left. There were a couple of clues that cubing was involved, but it's actually exactly works. So this thing is equal to 2 to the power of 30, which means that x plus 2y is equal to 2 to the 10, which is pretty good. We're basically done, right? I feel like we've solved this. I've taken a cube root on both sides. I suppose I'm not quite done because I need this to actually work with positive whole numbers. So what have I got? It looks like x is some even number, and then y makes up the difference. So y has to be whatever the difference is between this huge number and x. Positive whole numbers, so maybe not 0. X could be anything from x could be anything up to about 2 to the 9. I think I'm going to pick C. About 2 to the 9 because I want it to be even and between 0 and 2 to the 10. So I'm going to pick C. Not quite sure why there's a -1 there. I couldn't be bothered to think it through very precisely. Depends if you count 0 as positive or not. I don't think they do for this question, but come on. Yeah, okay. So if 0 is not positive, then you have to start counting with 2, and you have to stop just before you get to 2 to the 10 for your value for x. Good. Okay. So we got that. That's the sort of thing that we would like to do. This is 2009, Tara. Sorry. Anti-binomial factorization. Q6 and Q7 are 2 of the options today, I think. Is this not 2009 or 2010? Have I lied to you? Pretty sure this is 2009. Don't get there's a number of pairs of integers. Sure, okay, so over here, I've got to find integers that satisfy this thing. So what could x be? Could x be 1? No, because then 2y would be 2 to the 10 minus 1, which is not good for y to be an integer. Could x be 2? Yes, but then 2y would have to be 2 to the 10 minus 2, which has a solution. Y is like 2 to the 9 minus 1. So this is exactly one pair like this. In pair in that order, x is 2, y is 2 to the 9 minus 1. And we can keep going. In fact, x has to be even because of this sort of reasoning. So the next one is this. And then the next one we will keep going. And these keep going until you get up to 2 to the 9 minus 2. 2 to the 10 minus 2? 2 to the 10 minus 2. Because then 2y can be equal to just the number 2, so y is just the number 1. So there's kind of decreasing counts going on for the values of y, and increasing multiples of 2 for x. That's not a sort of maths that I've used very often in other things, but just trying to logic my way through it of what the possibilities are, given that these are positive integers. Tara's got a different 2009 paper. Chat, what's going on? How would you recognise this? Sure, so I guess the clue for me was the cubes, that this x cubed. There's also the kind of pattern of the way it goes: x cubed, x squared y, xy squared, y cubed. Which is not just random polynomial terms or random powers of x and y. There's some sort of logic to it, with like a x squared y to the 1, x to the 1 y squared. I suppose also there's quite likely to be something going on, because otherwise this is just extremely hard to solve, right? It's got 2 variables in it and 4 terms. It could be really nasty. There we go. Oh, that's now awful. Don't like that at all. Let's turn that down. There we go. Okay, but I think that's 1J. Herb thinks I'm doing a secret bonus paper. Good, right, cool. I'm pretty sure I just downloaded 2009 from the website. It's not a problem I expected to have. In the mat, if you want to use the sine double angle formula, this is a good question. Let's put it on screen. Oh, we've still got a poll going. Sorry, poll. I'll look at the poll in a second. If you want to use an identity like the double angle formula, there's differences, right? It's probably not going to be useful, because we try to write the questions so that people who don't know the sine double angle formula can do them. If it is, then it's worth writing down something like, this is the sine double angle formula, or write it down that you have some sort of justification for why this is true, even if you're just quoting, this is a thing that I know from school. It's worth doing that. I'm not saying you have to prove the sine double angle formula. I'd also be really careful, because often the questions tell you how you're supposed to do the question. We're on multiple choice at the moment, so anything goes. But for the questions where you show you're working out, often they give you an instruction about how to do the question, which is unlikely to be using the sine double angle formula, because that's not on the syllabus for the math. So there's a question about scrap paper in there as well. Andrea, the answer booklet has lots of blank pages in it, lots of space for you to do working out. It's got pages for working out for question 1, even though for question 1 it's just multiple choice. We're keeping pages for you to show you're working out. You're actually going to have more space for question 1 than ever before, because normally the answer booklet also contains the questions. We've normally just had question and answers. The answer booklet is the question booklet, but this year the questions aren't printed in the booklet, so you've got more space than ever to show you're working out. And there's this kind of thing about, we're not planning to change question 3. Question 3 is different every year, so we're changing it in that sense. But just, maths and computer science students have always done question 3. How do you know if they count 0 as positive? Yeah, that really threw me. I think 0 doesn't count as positive. I'm really glad that they didn't put 2 to the 9, because some people count 0 as positive, I think. Some people do. So I'm really glad there wasn't a 2 to the 9 option, because I think either would be defensible. Is it just one bonus option I get, or is it 2? I think I get 2. 2 to the 9 plus 1 would be my alternative option, I think. Right. 2 to the 9 is not an option. Okay. Yeah, I'm a little bit suspicious about this. Let's say that 0 is not positive and see how far that gets us in life. And there's a request from Anonymous for me to publish the sample answer booklet. It's in the last stages of approval at the time of recording. At the time of being live, it's in the last stages of approval. As soon as it's approved, I will put it on the MAT website, which is where we put MAT resources and things. It's really not a very exciting resource. It's pretty similar to an old MAT paper, except without any questions on it. So mostly blank pages. I really don't want to hype anybody up for the sample answer booklet of mostly blank paper with question numbers. Okay, right, good. But I know that some people like to say it. The paper's definitely been written. 0 is definitely a natural number. Oh no, that one's controversial too. What do we need more space? There's space at the back. There's more space than there's ever been. Right, okay. Strictly positive is something we say in English as well, sometimes, but not reliably. Is it already on the MAT website? I don't remember. Moving on. Cool. Can you circle multiple choice in the table thingy? No, please use the table thingy. Especially this year, there's nothing to circle because this year it's just a blank answer booklet, which you'll see soon. Hi everybody in chat. New specimen paper. Oh, we got loads of past papers now. The past papers are a bit like session papers. Right, what do people actually vote for in the chat? I wasn't looking. I'm switching this back on so I can see it. Oh, it's 3 and 5, and it's kind of a draw. So there's our direction then. We're going to look at 3 and 5. Let's go. Oh, 3's good. I like 3. 3 wants us to talk about this function. Can I put this on screen as well as chat? Yes, I can. There's no extra paper beyond the paper that's provided. It's quite a lot of paper. I think you wouldn't need extra paper too. Good. Okay, let's do question 3 from Matt 2009. I think. Sorry, Tara. Tara, you appear to be in some sort of alternate dimension. Could you let us know in chat what your question 3 is? This might be a good way of getting new Matt questions. Sorry, Tara. Okay, so we've got a function. It's to find f subscript n of x. So the number n is important in the function somehow. And here it is. It's x to the power of 2n minus 1, then take away 1, and then square it. And the question wants us to immediately start thinking about f2 of x, which is the same thing but with n replaced by 2. So I'm supposed to think about n replaced by 2 is x cubed minus 1 and then squared. So I've got to think about what this is. So first I'm going to think about x cubed minus 1, which looks like this. And then I'm going to think about squaring it. So if I square that, then when I square 0, I'll get 0. That was at 1. When I square positive things, I get positive things. So that's going to go up. When I square negative things, I get positive things. I had to think there. I think it flattens out over here and then goes up again. Why have I drawn it flat there? Because, I guess it's kind of flat over this side, and if you're squaring similar things, then you get similar answers. So it feels like it should stay flat. Yeah, that's also true, so that's nice. Oh, that's right underneath chat. This is the danger of having chat on at the same time. Hey, there we go. Once again then, it's 0 where the original function, x cubed minus 1 was 0. Positive things square to positive things. Negative things square to positive things as well. So I've tried to draw this with a kind of 0 at 1. I think that's a repeated root. It's going up again. I guess I could expand to this if I really wanted to. I regret that. That's not really told me anything at all. I guess it showed me there's no derivative at 0. And made me think that this is sort of like an x to the 6 kind of upward pointing thing. Anonymous. Should we cross out any rough working and write our final answers neatly? I don't think you've got time, so I would leave rough working. The markers are used to marking rough work. Tara will exist forever. Can't see the graph because it's behind chat, but I wasn't looking at chat at the time. Sorry, Andrew, I've now hidden chat. Yeah. Ooh, fun. Good. Same axes sketch. So on the same axes, but I'm going to do different axes because I'm like that. That is beeping, which is annoying. Let's sketch this where fnx, where n is a very large positive integer. Let's go. So x to the 2n minus 1 will be really a huge power of x, and that's an odd number, 2n minus 1. So the graph of x to the 2n minus 1 is going to be like this. Ooh, and I know that from experience of messing around with polynomials in Desmos. I've just looked at polynomials, and when you get a really high power, x to the n for really large n, things blow up quite quickly. So AF in chat says boxier and steeper, so I think that's good. Sort of this comes from the fact that if your number is greater than 1, then x to the large number is like really, really big. This is not scientific notation. X to the 1001 is really, really, really big. And just smaller than -1, something similar is true. X to the 1000 is really, really, really big and positive. X to the 1001 is really, really, really negative. That's quite subtle, I suppose, that dependence where 3 out of 4 cases there are really, really positive. There's this one weird case which is really, really negative. Again, that's something I found out by just messing around with polynomials in Desmos, but also makes sense algebraically. In between, I've drawn it really flat because things between -1 and 1 for large n is roughly 0. So it's kind of 3 things that I know about powers. Anyway, why am I doing this? Because now I need to square these things. So I've got extremely positive numbers over here. I'm going to draw something that's extremely positive. I guess it's going to have to come down to 0 over here. And it's going to be pretty much 1 throughout this region and then extremely positive over here. So I've got this kind of like boxy thing that looks like a finger pointing down at the root. There, that's where the function is 0. Yeah, in chat. It is important whether the power is even or odd. We know that 2n minus 1 is odd. What would it be like if the power was even? Well, if the power was even there, then the function would be symmetric in reflection in the y-axis. So it would be like, it would point down to 0 in 2 different places if that was an even power. If you like, then the dotted line of x to the 2n minus 1, didn't say that very clearly, x to the even power and then minus 1 would be like a boxy shape that's positive in 2 places. It crosses the axis twice. So it does matter that they've given us this thing with 2n minus 1 instead of 2n up here. The graphs, if we're asked to draw these on the same axes, which I've ignored, I guess you would maybe point in the fact that these go through the same point in here. If you put in x equals 0, then it doesn't matter what the power is. This is just -1 squared, which is 1. So when you draw these on the same axes, they will go through some of the same points. Where it's flattish, that is near, so including this point is near y equals 1. For numbers between -1 and 1, when you raise them to a huge power, you get something that's basically 0. Then you subtract 1, you get about -1, and then you square it and you get 1. Cool. Okay, messing around in Desmos. Good. Okay, going to move on in a second. We're going to do this integral. I think for the integral, I am going to multiply it out. Not super looking forward to these inequalities later on, but you get marks along the way, right? These different parts of the question are worth marks, so I'm making progress. The mark scheme breaks down, this is worth 4 marks, this is worth 2 marks, so it might have already got 6 marks, which is all right, I suppose. I'm putting the numbers on because starting this year, we're putting the number of questions for each part on the questions in the exam, so you'll be able to see, hey look, there's marks all the way through this question. You get marks for doing stuff. This is only 2 marks, which maybe clues us in that this part is going to be not too bad. I'm going to multiply this out. I don't know how to integrate a square of a function, but luckily I do know how to integrate polynomials, so I'm just going to try and do that integral, I guess. In the actual exam, you'll see the questions on a computer screen, but you will write your answers on paper on an answer booklet. This is for the 2023 exam. You will not do what I'm doing, where you try and write your answers on top of the questions. That's something I'm doing, so I can show you everything at the same time. You have there's an official answer booklet where you'll put things like your name and candidate number, so we know whose work we're marking. Good. Okay. Drez in chat wants to use reverse chain rule, which is quite exciting. It's got me thinking. That does not look like the chain rule, and at least some people watching don't know what the chain rule is. I'm not going to use the chain rule. You're welcome to if you want to. Are we supposed to label any points? Oh yeah, we were supposed to label where the graph meets the axes. Oops, I skipped that entirely. 1, 1, done. 1, 1, there we go. Okay, let's do these. Let's do these integrals. The rule is you add 1 to the power, divide by the new power, plug in 1 and 0. I'm accelerating. Cool. Something like that. I think that simplifies to 1 over n or something. Plus 1, where I've skipped some steps. If you don't believe me, please practice integrating this polynomial. Depends on n, but not in a very scary way. I guess I'm using the fact that n's not 1/4 and n is not 0. I'm doing some dividing, so I should worry about that a little bit. Cool. I'm not sure you can do a substitution. People in chat are talking about advanced ways to do this integral. I would really multiply it out and integrate the polynomial. That is absolutely what I would do. Okay. If I got away with doing this, like just going for it, this feels like a good exercise for people to try at home if they want to. If they want some practice integrating polynomials, and like the sort of thing that I should not do in small pieces on the stream. We'll find out, right? Let me know in chat if you want to see some polynomial integration. These parts often link together, right? So there's something to spot here, which is that the stuff on the left-hand side for part 4 is the thing that we just calculated. So I'm writing down the thing that we just calculated. So we have this. This thing is true for all n bigger than or equal to 1. We've been asked to show something which looks quite complicated, but it looks like something's been multiplied up, right? So this n plus b is now upstairs. This 4n minus 1 is now not in the denominator of a fraction, it's upstairs. So my kind of optimism is that if I just multiply through by the denominators of all the fractions, that stuff will just work out. Maybe this is wishful thinking. I've noticed that both sides have a plus 1 in. Expanding it is a lot better. I'm not actually convinced by this substitution plan. I think you should maybe go for it. Yeah, there will be a practice there will be a specimen. We're going to format a past paper in the online computer screen formatting and make that available. That's almost ready to go out. If you enjoy the MAT Livestream, you are a little bit ahead of the other resources that are being prepared. Sit tight and keep doing maths. So that sounded really patronising. That was supposed to sound like a flight announcement. It didn't really, did it? I'm doing some cross multiplication. You'll maybe cross with me, in which case you can do some cross multiplication too. Counted as a joke, believe it or not. Right, what am I doing? I think I'm trying to simplify this left-hand side. I'm a bit worried that it doesn't look like it's going to simplify correctly. Oh, both things have got a factor of n plus b. Yeah, maybe I should have simplified this fraction first before doing my cross multiplication. Yeah, maybe I should have done that. Take off the 4n's, you get minus 3n, so n take away 4n. You get a 1 here. I'm a bit worried about these minus signs. I'm hoping that will just go away. Yeah, so you multiply both sides of minus 1, and that fixes all your problems, but also flips the inequality sign around. Remember how inequalities behave when you multiply both sides by a negative number. It flips them. Plus x instead of plus 1, right? Oh, right, so it was a plus x, but then I plugged in the limits of 1 and 0, so I got 1 minus 0, which is 1. So yeah, I think I did that too fast. Yeah, so part 4 does come out of nowhere. Anonymous is correct. Yeah, why would you say, given this expression, why would you say that it's less than 1 minus a over n plus b? How do they know that? And I suppose we're working out that this could be true. We're working out some limitations on a and b to actually make this true. So this has kind of been asserted. Suppose this is the case. We're scrambling to think, does that actually make any sense? Are there some numbers a and b that work? So we've got this statement here which is supposed to be true for all n. You should always be a little bit suspicious when you see a statement that's supposed to be true for all n, right? Especially if, like this one, it's a comparison of two sort of quadratics in terms of n. you should be a bit suspicious. Is that left-hand side really bigger for all n? Not if a is a huge number, right? So it's supposed to be true when n is 1, true when n is 2, true when n is 3, and so on. True when n is a million. And if n is a million, then the thing that really matters is that that right-hand side is roughly 4 times a times n squared. Or if that's not convincing enough, consider making n even larger, kind of limiting behaviour of the right-hand side. Or if you prefer, shuffle everything over onto the right-hand side and make sure this is a quadratic that has a negative coefficient of n squared, an unhappy quadratic. Or shuffle everything over to the left and make sure that this is a kind of positive quadratic, happy quadratic. In order to be always positive, always bigger than or equal to 0. We're not out of the woods, having done that, of course. But we need some B factor to also make sure this is true. Right, okay, I think I'm going to think about it like a happy quadratic. I'm going to move everything over onto the left, multiply everything out, just so I've got like this quadratic that I'm talking about, but try and rearrange it. Excuse me. This is a past paper from 2009. Anna F in chat has told me they've rearranged. I don't know what they've done actually. Have they plugged in a special number? No, 1/4 minus 3b. Where's that come from? Anna F has done something in chat, which has got 2 thumbs up. And I've got a request to actually do the steps in part 3. So I'm going to go back and do that in a second. And now we're rearranging. Yeah, if it's true for n, it's also true for n plus 1. So we could do some substitutions. I guess. I worry that will make it a bit more messy. It's already a bit of a mess, isn't it? Look, I'm going to move it around into the quadratic that I'm talking about, just to see what happens. So on the left. And on the right. That's a bit clumsy, isn't it? 4a. I kind of want to write that as 4a, sorry. Doing my multiplication out, so this is 4a n squared minus 4an. Okay, so we've got this kind of 2 quadratics fighting. Let's make it even clearer. Oh, a is equal to 3/4. Anna's on the next part. I'm with you, don't worry. Yeah, take the limit as this goes. Gets really large. Can you make b be 0? Asks QZ in chat. I'm a bit nervous about making b 0 because I don't really know anything about b at the moment. I'm trying to work out what's possible and I don't want to remove any possibilities yet. So this quadratic, without talking about b yet, I can see that for this to be true, it's got to be a happy quadratic. So it's got to have 3 minus 4a bigger than or equal to 0, which rearranges to be this. If not, then for very large n, this will eventually nosedive and go negative. There's this kind of heuristic, I suppose, that or rule of thumb, that for polynomials, it's the largest power that matters when the argument is a really large number. If you've got a cubic, then you can get the kind of behavior for very large n or x, or whatever your variable is, very large behavior by looking at the cubic term, the degree 3 bit. Sorry, the whole thing is degree 3, by looking at the power, the x cubed term. Do our students ever do step just for fun? Yes. Yeah, we don't really care about this n squared thing for large n, so we need this thing to be. Please. Okay, and then part 5 asks us to plug in a equals 3/4 and talk about b. If we do that, then we'll get, so this term will go away. We're not out of the woods though. We still need 3b plus 3 n take away b to be bigger than or equal to 0 for all n. And that's a linear thing, isn't it? Do I mean 3b plus 3? Yeah, I think so. That's a linear function. Yeah, no, think I've messed up something in here. 3bn plus n over here. There's a plus n right here. Nobody told me. Oh yeah, there's a minus signs and plus signs all over the shop. This is a terrible multiplication out. Nobody look. Alright, what have I multiplied out? I actually multiplied out this. Yeah, I lost an n. Lost an n inside here. Which is quite bad. 2 seconds please, technical difficulties. Let's put up the technical difficulties slide. Yep, -1 inside here. Nobody's perfect. Oh, now I'm really scared. Once you found one mistake, right? You've got to be on high alert for further mistakes. Yeah, I'm really not convinced by the thing I've written down. Like, really, really not convinced. Oh yeah, the right hand side hasn't gone away. I've lost the 4a as well. I'm dropping terms all over the place. It's terrible. 4, 12b, 3, help! I agree with Michael in chat, because I've done this before. I got some numbers. If we're unable to do part 4 for any reason, is it fine to continue to part 5? Yeah, I think that's fine. Yeah. It's not always the same markers, but at the moment it's always the same person leading the team of markers, which is me at the moment. Leading the team of markers. I would give marks to part 5 even if people have got part 4 wrong. Why is it 4an, not an? Yeah. What am I doing? Yeah, I can't multiply out. Thank you, chat. Thank you. Oh boy. Once you make one mistake, you tend to make more mistakes. Nobody's perfect. There we go. Okay, so for this to be true for all n, I would need that coefficient to be a positive number. So this was a kind of upward pointing linear function. And I'd also need the value when n is equal to 1. Positive constants, positive n bigger than or equal to 1. I would also need the value when n is 1 to be positive. So it's got to start strong. How am I going to draw that? There we go. I'd need the value when n is 1 to be positive, and then I'd need it to keep being positive forever. There's kind of 2 conditions. And put together, it turns out that we need 2b minus 1/4 to be bigger than or equal to 0. That's checking that this thing is actually positive when you put in n equals 1. And we'd also need 3b minus 1/4 to be bigger than or equal to 0. That's checking that the coefficient of n is positive. So we need this thing and also this thing. Putting those together, that means that b has to be at least as large as 1/8. The smallest possible value of b to do both of those. Thank you, Andrea. You spotted my chat. Yeah. Markers follow my mark scheme very strictly, but there's always a little bit of people always surprise us by writing different things. Is this how you feel for every problem? Anonymous in chat. How did I multiply this out so badly? I guess I saw the 4 and I was imagining the 4 belonging with the a, but I only wrote it down. I wrote a 4n squared and then I was thinking about 4s. It's nice to go back to a mistake and analyse why you made it. I can also rewatch a video of myself making the mistake if I want to see what I was saying at the time. I don't recommend that, by the way. Don't record yourself making mistakes. Premises minus 3/4. I also lost this -1, so a is positive 3/4, take off 1 gives me -1/4. Whew. Yeah, okay. Positive quadratic doesn't mean that it's... Yeah, so this is technically what we're checking up here with this quadratic checking thing, where we checked that this term up here. Technically what we're checking is necessary but not sufficient. It's not actually enough just to check that the positive term of that quadratic is positive. I guess you're worried about this sort of thing, right? Where it's eventually positive for large n, but there's some problematic values of n in between. And that can still happen. And in particular, that does happen if if A is equal to 3/4, then you're not out of the woods. Or I guess even if A is a little bit smaller than 3/4, you're not out of the woods. You've still got to check that when n is 1, 2, 3 or something, there aren't some sort of small values of n that get away. So this is quite hard to check. I can sort of see how I would do it, I suppose. But this is quite hard to check in general. If A is not equal to 3/4, we'd have to worry a lot about the minimum value of the quadratic. So we have this quadratic on the left, and if that first coefficient is negative, then it doesn't even have a minimum, it just goes down. But if that coefficient is bigger than or equal to 0, then this thing has a minimum, which we could find across the positive integers. Yeah, so Andrew, that 2b minus 1/4 comes from the idea that similarly over here, in this very special case where A is 3/4 and the thing's simplified down quite a lot, we're checking that we want to check that this coefficient is positive so that it's not the case that our function is nosediving like this. We want it to be bigger than or equal to 0 for all n. So that's why we're checking the coefficient. But we're also we're looking out for this case where it's eventually positive, but it started off negative. The way we detect that is by plugging in n equals 1. For n equals 1, I get 3b minus 1/4 minus b, which is 2b minus 1/4, that thing I wrote down up here. If we check that that's positive, then that avoids this case, because it'll make sure that we start positive and stay positive. This is quite technical. This comes from thinking about function on a restricted range. There's a bit of fun you can have here. So general follow-up kind of exercise that you might like. You're very familiar with the function x squared. I'd like you to take some sort of interval, like a, let's think of x, let's think of b, and I would like to know the possible values of x squared. I suppose the question is something like, what are the... There we go, let's make it a question. And this question is quite hard. It looks really easy, but it's actually quite hard. Thinking about the range of functions on a restricted domain is pretty hard. Someone in chat has maybe heard the phrase necessary but not sufficient for the first time, which is a phrase I've heard in maths lectures quite a lot, so I'm pleased that someone in chat's heard it maybe for the first time. It's also a good argument phrase, I suppose. You can use. You want to admit that something, necessary but not sufficient. You've turned up to work. That was necessary, but it's not sufficient. It's not enough. You've also got to do a good job now you're here. Necessary but not sufficient. Do you want a medal? You put trousers on this morning. That was necessary but not sufficient. You can use it in all sorts of contexts. It's great. The working out does not have to be that convincing. We are looking to make sure that you had the right kind of idea. Here I have not written down enough reasoning. I should really, if I want these marks, I should really write down why. I think I said it out loud, but didn't really write down. How can mathematicians at arguments? Ranges. It ranges. Depends what the argument's about. Okay, is this a robot question? This is not quite a robot question, but it could be a robot. I think I'm going to imagine there's a robot doing this question. We're moving to question 5. It's 5:45. We're going to do this as fast as possible. Quickly answering questions in chat as well. It's a little bit multitasking. To try and do everything at once. Other universities get told your MAT results almost straight away after the MAT's been marked. They get the results before you do. I don't know how fast Tamura is. I think Tamura is also quite fast. I don't work with Tamura, but we get the MAT results to other universities as quickly as we can, which is pretty fast. What did we name the robot? We named the robot Robert last time. Robert the robot. According to website Carbon. Ooh, I've learned a new thing. A website carbon calculator. Websites have a carbon footprint. Ooh, is it just got too much stuff on it? You get your MAT results in January. which is also the sort of time that you get told final decisions. If you had an interview, you find out in January whether you have an offer from Oxford. Okay, time management for Matt, stress of timing. I have stress advice, which is kind of separate from other stuff, but timing, you're going to do a past paper, not yet. We've got a couple of months, so I wouldn't do timing practice yet. The main thing that you need to be able to do is to move on, to look at other questions, to give them some of your attention, to just pick up marks on other questions. You'll feel much better once you've got some marks on each question, and then going back and polishing and putting extra stuff on. But I think you'll feel less stressed once you've done at least something on each question. The questions are supposed to be structured so that you can make a start, and I think you'll feel better once you've made a start on them. Probably how I should approach tests. It's not how I actually approach tests, because I'm an idiot and I just do things in order. You can do better than me. Right, which university can see your math score? Ones that you give permission to. So Imperial and Warwick have got there's tick boxes when you register for the MAT. Durham and Bath have got a kind of more complicated system where you can give them permission to see your MAT result. But it's universities you give permission. Advice for question 5. More advice? Yeah, so the question 5 is often quite basic and don't use very much syllabus maths. We're going to see that in this question when we talk about it in a second. Have I just started talking to chat without having chat on screen? I think I may have done that. Yeah, I'm talking to chat, but you can't see the chat I'm talking to. Never mind. I think we should just try and do it and then see what we learn along the way. Got one eye on the clock as well. Right, good. Trying to get started with this question before I get another chat message that says please get on with it. I see you. There's an anonymous person in chat who will post get on with it if I talk to chat for too long. I think I beat the clock this time. Right, let's go. A tour is a path drawn within a grid such that along its way path moves horizontally or vertically, not diagonally, from the centre of one square to the centre of a chicken square. Okay. Path starts and finishes in the same square, like that's good. Paths with the centre of every other square just once. Here's a 6x6 starting finish in top left square. I do like question 5s. I think they're often quite mathematical in the way that they use quite basic maths. Right, okay. N is even. Assume for parts 1 to 4. Wait, how many parts are there? 5. Okay, not possible when N is odd. Interesting. Aid of a diagram. Oh my goodness. N by N grid. N is even. Oh my goodness. Okay. Not like this, right? This looks complicated. What do I want to do? So I've got N by N grid. I think I'm going to try a 2 by 2 grid first. Wait, no, that's too easy. I think I'm going to try a 4 by 4 grid first. So I've got to visit every square. Can I just go down? And then I've got to visit every square. If I go up now, I'm going to block off my exit. So I'm going to come back down again. I've drawn a pair of trousers, which is necessary but not sufficient. 6, 7, 8. What am I doing next? What's the next even number? The next even number is 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I need to draw 7 lines so that I get a 6 by 6 grid. Phew, drawing is hard. Okay, so I'm going to try and do the same thing with like trousers, but with more legs. Yeah. Okay, and then because N is even, okay, N is even. Because N is even, the like legs of the trousers, that's more of a M shape, I suppose. The legs of the trousers will go down and then up, down then and up, down then and up. And then we'll finish by going along the top. So that's how I do a tour. Down then up. I would write out some of that, I think. Not like that. I would write out a couple of sentences that I've tried to say out loud. Trying to explain this kind of idea of going down then up again. It's good that N is even. Is it still possible if you start at a different square? Yeah, sure. Yes. Follow the previous tour. The previous tour went everywhere, right? But start somewhere else? This is a bit daft, I think. I think I've understood the question. I think it's daft. If your tour visits everywhere, then in particular it will visit this different square, whichever one you pick. Yeah, sure, we were going to go there anyway. I guess we can start there if you like, but then we'll just do the tour and we'll come back around again. So I think that's fine. I think very short explanation. Let me check how many marks this part of the question was worth. Again, this year we are typing how many marks each part of the question is worth on the question for the first time. So that was worth 2 marks. Interesting. Yeah, and the web solution thing says pretty much the same thing that I've just said out loud. While I'm writing numbers, I'm going to write 3, 3, 4 down the left. Pretty even spread of marks on this question. 5 parts, roughly worth 3 marks each. There is a robot in this question. Here it is. Robot is called Robert. That's not in the question, but it is in my head. They're programmed to move along the tour. Brilliant. Good job, Robert. The robot understands 2 commands. The command R, which turns the robot clockwise to a right angle. Clockwise. Which way is clockwise? Wait. Clocks. Okay. R. Okay. And F, which moves forward. Okay. The robot has a program. List of commands provides performance in a given order to complete a tour. Say that in total the command R appears R times and the command F appears F times. It's moving forwards into new squares and it's going to visit every square exactly once. So it's going to have pointing to the right. Assuming the first command is an F, what is the value of little f, the number of times the F appears? Why does it say assuming the first command is an F? No spinning at the start? No, I don't know why it says starts with an F. Because the number of forwards moves is the number of squares it's supposed to visit. I guess -1, because oh no, it needs to move into the start square as well when it gets round. Every time it does F, it visits a new square, and it also has to visit the start square at the end. So it's going to be n squared to visit each square. And R plus 1 is a multiple of 4. I'm a bit confused about why it can't just sort of spin at the end. Why can't it just spin at the end? Hi, chat. Oh, they want me to go right first. So if I go right, right, okay. So I go right first. I'm in the top corner, and they're telling me that the robot starts by going right. Well, starts by going forwards, which is to the right. So it's going to end by coming in. But is that the last command? Well, I get that as it's come in, it's rotated it's rotated a certain amount, so we could talk about how much spinning it's done throughout the motion. I'm not sure why it doesn't spin to celebrate at the end. Chat, help. Yeah, so I initially thought n squared minus 1 as well, chat. Someone in chat is saying n squared minus 1. It's Andrew. Hi, Andrew. I initially thought n squared is minus 1 as well. That's how it visits every other square, sure. To complete the tour, it's got to get back to its starting square, so it's got to do 1 more F. So if you think about it like that, which is how I was thinking about it too, then you have this slightly convoluted thing, which is like n squared minus 1 plus 1, where it's done n squared minus 1 to visit every other square, and then 1 more F move to get back into its starting square, ready to sort of complete the tour. I guess the tour goes all the way around. It's this is not a tour. It's got to do that last extra F move, the 4th one, to get back to the starting point. In case n equals 2. Yeah, okay. So it's just supposed to stop. Ready to. Is it supposed to finish pointing to the right? No. Okay. If it finishes pointing upwards, then R plus 1 would be a multiple of 4 because it finishes pointing upwards. So 1 more turn would point it towards the right. 1 more turn would point it to the right. So R plus 1 is enough rotations to get it pointing to the right. I'm writing behind my head, aren't I? R plus 1 is enough rotations to point same direction it started. It spins 90 degrees each time, so r times 90 degrees is some multiple of 360 degrees. That's probably overcooking it a bit. It says that r is a multiple of 4, dividing both sides by 90 degrees. Do they still hold if the robot starts and finishes at a centre of a different square? I guess it still does n squared forward discovery moves, discovering squares, but I'm not convinced about this spinning thing, because I reckon it could come in from a different, like it could come in my trousers diagram. Let's try and draw a better version of the trousers picture. That's not better, that's just smaller. In the trousers diagram, if it starts at the centre of this square, then it starts coming in pointing upwards. If it goes around clockwise, then it starts, it will face upwards as it leaves this thing. So I'm not sure about the spinning thing. I think the spinning thing, so counterexample, I think if it does the 4x4 path that we had before, but starting in one of the other squares, then I think its total rotation is, in this case, 3 more than a multiple of 4. Because it started right, facing right. I picked a terrible counterexample. Yeah, I think I picked a terrible counterexample where it's not even true. Let's make it start over here and go round the tour like this, in this direction. So then it'll start facing right and it ends up facing down. So in that case, r minus 1 is a multiple of 4 rather than r plus 1. I guess this thing about at the end it's facing up, it's walked upwards is just not true in general. So we should find a counterexample where it finishes not facing north. Yeah, the first counterexample I tried to do was not a counterexample because the thing was still true in that example. It's annoying that that can happen. You can have a false statement and you try and find a counterexample and you write out something that's actually an example, not a counterexample. Oh, Anonymous thinks my counterexample was right. I think I got by the fact that it starts pointing to the right, whereas what I'd like is if it started pointing along the direction of the tour, and the first command is an F. Yeah, what if I'm assuming that? So if I'm assuming the first command is an F, that's no longer possible with either of the examples that I've got. So it's kind of technically not quite a counterexample. I'm getting a bit tied up in knots here. I'm now considering the counterexample. Start here in the middle of this square. Do this tour. Then the first move, it starts facing right. The first move is an F, but it comes around and it ends up facing right. So the number of right turns it's done is not a multiple of 4. Counterexample had 12 right turns. So, right, okay. So it depends if you. I'm getting a bit confused about the idea that the robot starts pointing to the right. I'm not sure if that's part of the thing that we're changing. So we're given this, in part 3, we're given this initially the robot's in the top left square pointing to the right. And then we're asked about what if it starts and finishes at the centre of a different square? And I'm not clear whether we should still assume it's pointing to the right at the start and the first move is an F, or whether we're tweaking that. Not the clearest question writing, or maybe I've just confused myself. What's chat think? Right, down and up, make some U's. So in an even column you had to turn right to go down, because in an odd column you don't have to make the right turn. These questions are also quite hard to mark because people write all manner of different things to explain why something's not true. In general, if something's true, then people write quite similar stuff. If something's not true and people have to show a counterexample or give a reason why something's not true, then there tend to be quite a lot of things that people write down. It's hard to mark. Yeah, just to be safe, for anyone, I'm going to do absolutely, just to be safe, and draw a nicer picture. I'm going to give an example of the robot starting here, facing right, first move is an F, then the tour goes forwards, right, forwards, forwards, right, right, forwards, right, 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 forwards, right, 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 forwards, forwards, right, forwards, right, forwards, 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 right, forwards, forwards. And that was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 right turns before it completed its tour, which is a multiple of 4, not one more than a multiple of 4. Oh my goodness. I just think it's slightly, when you start changing the assumptions, you should be clear about which assumptions you're changing. And there's possibly slightly different interpretations of this question, so it was probably marked in quite a generous manner. What did the mark scheme say? Or the web solution, what did the web solution say? Going right along one of the flat parts. Yeah, they've picked a flat part. They've picked something like this. I'm still not clear why the robot doesn't do a celebratory. I think all of this is ruined if the robot does a celebratory spin at the end. Or the kind of really true fact underneath is that if the robot has to spin around to end up pointing to the right again, pointing, or let's say pointing in the same direction it started, ready to do the tour again, then it has to have turned a multiple of 4 times because it's now pointing in the same direction it started. But maybe that's too easy, so I don't really know why that's not the question. It's kind of there is this nice fact that in order to end up where it started, it has to turn a multiple of 360 degrees. And the question is kind of like, if it doesn't have to do that, then it's not the case that it has to turn a multiple of 360 degrees, but oh well. Tour is not possible when n is odd. Why is that the case? It feels like a parity sort of thing, doesn't it? Each move. No, let's try it out on a 3x3 grid and see what happens. So there are these corners. The corners are interesting. They all join up on this 3x3 grid, so that's not possible. On this 5x5 grid, is it the corners that matter? The corners, if you're trying to join things up on your tour, how are you going to do it? The corners are interesting to me, but I guess the corners were there on the even grid as well, so what am I saying? Did I just disprove 3? No, because in 3 I'm told the robot starts in the top left square, which is a very special case. For part 4 I found a different square where it was no longer quite the same. You don't think celebratory spins break it? But then the command R, like the command R would appear an extra 37 times or 38 times depending on the celebratory spinning. And that would still complete the tour, and it would be a list of commands. I think we're assuming it doesn't do any unnecessary spinning at the end. Otherwise you can't say anything about how many spins there are. This year's math past paper. This year's math past paper. It'll be a past paper once it's happened. Maybe that's a nice way to think about it. It's just one more past paper. Oh, so it's going to step every time it steps. It's an odd or even thing, right? Yep. No. Every time it steps, it'll explore a new square. If it does n squared forwards moves, yeah, it feels plausible, then it'll have moved. Okay, so if you colour in the squares like a chessboard, then, which I know chessboards have an even number of squares along the side, but if you cover in the squares like a chessboard, then every time it moves, like a checkered flag, every time it moves forwards, it moves from a black square to a white square, or from a white square to a black square. It alternates. And if it's going to do a tour, then it's going to visit black square, white square, black square, white square, black square, white square, black square, white square, black square. But along the way, then, it'll visit the same number of black squares and white squares. So it won't visit an odd number of total squares. So tour alternates black or white squares, so has even length. Oh dear, that's not all the squares. That's hard. That's really tough at the end. What was I about to say about this year's paper? Oh, it's supposed to be similar to previous papers. It's not supposed to be harder. Your working out gets marked for the long questions. That's the plan anyway. Cool, right, okay. We did a couple of long questions. Do we want to do any of the short questions? I've just completely lost everything, it's gone. Let's have a look at the poll. Let's see how we're doing. Did any of the short questions get any votes? Oh, 1A got loads of votes. Let's have a look. Let's look at 1A. 1A's nice, right? Got to do an integral. It's a bit like question 3, isn't it? There's a theme here. You've got to multiply out the square, chat. Got to do the integral. You can calculate this. Maybe I'm not being helpful by calculating this quite quickly and incorrectly. If I calculated that right, I think I did that right. But you know, that's a quadratic in A. You can calculate I of A, and then you're good. Oh my goodness, what is that? Plus 1/5 minus 1/4. No, surely not. I've messed up somewhere. Will I spot it in time? Let's go to an ad break. No. Oh, there's an x squared inside here. I can't square. There we go. And then, you know, like fix all the squares and stuff. Being able to fix your own work is good for you. Right, okay, that's good, because now it's 4/45 or something. Is it B? Yeah, it is. Good. Cool, okay. Chat also voted for 1G and 1J. We had a look at J, so I'm going to quickly look at G. Oh, this is really good. You should give this to Desmos. It's all the solutions for where sine y is equal to sine x. And in this case, y equals x is sufficient, but not necessary. There's the flip side of the thing we said before. It's sufficient, it's enough for y to be equal to x, but it doesn't have to be like that. You could have y is equal to x plus 360 degrees. Or this question seems to be in radians because it's from the olden days, so plus 2 pi. Or plus like 720 degrees. Or you could have y plus x being equal to 180 degrees. Is that right? I'm thinking about the way that sine goes up and then comes back down again. And that symmetry is like, you've got something over here like 30 degrees, and you've got something over here like 150 degrees. They add up to 180 and they have the same value of sine. And that's an interesting line because that's like a line with negative gradient. Which makes me think it's that kind of crisscross pattern in C. It's worth sticking in this in Desmos and trying it out with cosines instead of sines, seeing which points are in those things. Chessboard thing. Yeah, I skimmed over that, didn't I? Let's do the chessboard thing one more time, and then we'll do some steps because I remembered I said I'd go back. Yeah, sine x is equal to sine of 180 minus x. There you go. So the chessboard thing is, as you're going around your tour, you alternate between black squares and white squares. If you're walking on a chessboard and you're not allowed to go diagonally, you alternate between black squares and white squares. If you start on a black square maybe, and you go black, white, black, white, black, white, black, white, and you have to go all the way around, so you have to finish with a white square, and then you'll step again at the end to step back onto the black square where you started, or you'll start with a white square. Either way, you've got just as many black squares as white squares because they alternate around your tour. And you can't finish with the same colour because you've got to do that last step back onto your starting square. That means there's an even number of squares in the sequence of squares that you stepped on. Your n by n grid, the total is odd if n is odd. It was even if n is even, so that was fine. But if n is odd, then the total number of squares is odd. So, can't alternate and visit an odd number of squares total. How do I actually think of that? I suppose even odd and walking around grids. I've seen walking around grids even odd problems before, I suppose, with chessboard kind of things. They kind of parity argument I've seen in other problems, and now you've seen it too. Good. We have messed around with that one before, so Herb recognised the graph from previous experience. So this sort of thing that having seen stuff helps you out. Number of ops. Oh, of course, got a different thing. Right, hang on. Let's put this on screen. We're going to do another vote in a second. First, I want to quickly talk to chat. I said I'd do some integration of polynomials. I'd go back and integrate the polynomials in part 3, explaining the steps. Let's just do the first term. This goes to x to the 4n minus 1 divided by 4n minus 1. And then x to the power, you plug in 1 and 0, you get 1 and 0. So there's not really very much to see. You just get this thing upstairs is just the result of the x to the 4n minus 1s with 1 and 0 plugged in. And the thing downstairs is the thing that you divide by when you do the integration. Other terms work in just the same way, which is why I've written 2n downstairs. This minus 2 is from the minus 2 out the front, and then 2n. I guess I've integrated enough polynomials that I kind of know what happens when you integrate different terms, which makes me a little bit what's the word? Let's say fair. Number of ups equals downs, number of lefts equals rights. So f must be even. Yes, that works too. Yep, cool. There's another even odd argument. I call it keeping track of left-right motions and up-down motions, which is a little bit like colouring in the chessboard with 4 colours. So that, I don't know, kind of more than 4 colours. Anyway, it's a little bit like tracking the motion in a different way. So if you want to get home, then the number of times you went up a square has got to be equal to the number of times you went down a square. And separately, the number of times you went left has got to be equal to the number of times you went right. I like that. Yeah, there's no colouring in squares at all there. Good, okay. If you've been staring at the screen for the last hour and a half, then remember to blink, remember to drink water, stay hydrated. It's quite a sunny day in some parts of the world. We're going to look at some questions from 2010. I'm going to pick a question again, I think, but I want you to have a chance to vote as well. 2010's got some hard stuff in it, says one person in chat. So I'm going to put over to a vote for you so that you can tell me which ones you think are really hard. I'm also going to skim through them while you're voting. I think this is a good skill to have as well, to look at questions and kind of decide what's going on. Okay. So we've got a line intersecting a parabola, so sounds like solving equations, discriminant sort of stuff. There's some inequalities, feels like discriminants. We've got the sum of some terms. These things look like a geometric sequence, half, quarter, eighth, 16th. Over here we've got some equation with sine squared and cos squared in, so I'm really keen to replace some sines and cos, and I see why somebody asked me about sine double angle now. Excuse me, I'm thinking about squaring sine plus cos, I think, maybe. We'll see. Messing around with some sine and cosine stuff in here, try and rearrange it in terms of one of them. A graph question, sine squared is positive, so rule out A straight away. I'm going to cross that out now. Looking through the questions, see what's available, see what's going on today. Largest of these logarithms. I think we did this one in the logarithms live stream. So can we approximate some of these things or talk about how large they are? Bigger than or smaller than 1? One of these things is, if I think hard, I can remember one of these things is definitely not the biggest. Anyway, something like the trapezium rule. People voting for trapeziums. Who knows? Yeah, trapeziums are winning. No, J is winning at the moment. We'll get there in a second. We've got a complicated function in G. And then H has got, oh my goodness, an equation. Another equation, lots of things multiplied together. If n equals 3, so how many? Then it would be a cubic. No real solution. X for some values of k. That doesn't sound true. Okay, right. So it's talking about different polynomials over here with these roots. Solutions for any value of k. So we're going to have to think about drawing this function maybe with different values of n. It's got roots at 1, 2, 3 up to n, and we're interested in whether or not it's got solutions for k. It never has repeated solution. No, that doesn't sound true at all. K is a real number. Okay, right, good. I've got opinions about some of these. This looks mad. I don't think I can do this integral. I've got to do the derivative of this integral. Don't really want to think about that right now. And oh my goodness, finally positive whole numbers which satisfy this inequality. I'm thinking logarithms. I'm thinking sketching powers and multiplying things. 1j is winning the vote. Okay, so short questions, range of solving equations, sine and cosine stuff in there looks a bit hard. Differentiating an integral, not sure I want to do that immediately. Question 2 looks okay. It's got root 2s and root 3s, assuming some irrational number stuff. I've seen a proof that root 2 is irrational, so I'm feeling happy about that. Show that these things, okay. Counting some dots, multiple of 4, sounds like, can't be that bad, right? And oh my goodness, explain why there is a positive number. Right, okay, cool. Question 3, I remember this one. I've seen this before. Question 3 is not very similar to the way we currently do trigonometry questions. This question is very much about radians. Facts like this are just not really. You can kind of turn them into degrees, facts in degrees, but it's messy. This question is very much written in radians. And it also says you may assume the derivative of sine is cosine, which is not on the syllabus. So this question is, I think, no longer on the MAT syllabus in some sense. We can talk about bits of it if you like. I see that question 3 is doing well in the voting. I do think that means it's a hard experience for you doing this these days. If you've only seen degrees so far and you haven't seen the derivative of sine, then this question is using a load of stuff you haven't done yet. We might go in and find some marks. Stuff we can do anyway. 4 is this looks quite a mess. I think we did this one on a live stream recently. It's got this fact about the area of a triangle. We did this one a few weeks ago. 5 is a classic. It's about dates with repetition of digits. You work really systematically with this question. You do different bits at a time, working systematically through. I would look at the years first, I think. Question 6 has got some truth and lying, and this time they're sitting in a circle, and it gets really, really complicated. There's some overlapping things going on. And 7 is a recursion question with, oh my goodness, cat and mice chasing each other around. There's a table, and some sort of, this looks like some sort of recursion relation thing going on. G of h and m relates to, oh gosh, larger values of m, but smaller values of h. Ugh. Hope that works out. Good. Okay. Right. So 1J did really well in the vote. So I think we're going to do that short question as a way to get started. And then we're going to go and look in at questions 2 and 3. Let me try and circle those things. So 3, 2, okay, 3 in a row. Groovy. I was doing well at staying in time. Herb likes question 5. When would you start doing time practice? A few weeks before. I'm not sure that actually doing time practice makes you better at timekeeping. Probably makes you more stressed, but not sure how much I like that. Couple of weeks, yeah. Because the better thing to do with past paper questions is always to be stuck on past paper questions and try and get unstuck, which you can't really do if you're doing it in time pressure, because I guess you're going to look at the answers afterwards. Maybe I think that if you do a time practice, you should not look at the answers. It's a bit of a hot take, time practice, but then also at the end, keep going. Maybe mark down to yourself, like, it's been 2.5 hours. I'm going to keep going. There's a petition in chat for more time on the map. I don't think you'd enjoy it if there was more time. I think if it was 2 hours and it changed to 2.5 hours, I think that would make people very happy. And it is 2.5 hours now. People don't seem that happy, which makes me worried that 3 hours will make people less happy. Okay, right, cool. Let's talk about this then. So A, B, and C are positive numbers, and we're told there are finitely many positive whole numbers, x and y. Excuse me, we're asked, are there finitely many? We're asked to complete a sentence. There are finitely many positive whole numbers, x and y, which satisfy the inequality. Oh my goodness. A to the x is bigger than c times b to the y if, and then it's all going to be to do with whether a is bigger than 1 or less than 1, b is bigger than 1 or less than 1. I can see several possibilities there. Is that each of the possibilities? Yeah, so it's each of the possibilities for a bigger or less than 1 and b bigger than or less than 1. So let's think about this left hand side. If a is bigger than 1, then this left-hand side looks like a to the x. X is positive whole number, okay. Like that, going upwards. And that's if a is bigger than 1. C is a positive number. Right, okay, so I'm worried this one's got a C on it as well. So let's think about that a little bit. Let's try and draw this. What I'm thinking is if this one is going up and this one is going down, then this is a bit of a weird axis. Then there are infinitely many positive whole numbers x and y which satisfy the inequality, because just make x be something large and y be something large, and we're good. So not this case. Not this case. This is terrible, because then it's just like almost always true. So there's infinitely many solutions. So in this case, infinitely many solutions. Not what we wanted. X, Y, which satisfy it. I don't know why I'm writing in a column. So that kind of makes me think it's the opposite. I want to make A less than 1 and B larger than 1. So that there's only like finitely many examples where you have to take Y to be quite small and X to be quite small, so that it just works out. Let's see if I can draw a picture. So if A is less than 1, what am I thinking? If A is less than 1, then this side will come down, it'll start over here and it'll come down. And if B is bigger than 1, then this side will go up. So what does that mean? Does it count as finitely many positive whole numbers? I'm worried about when if C is quite large, then I think there are no examples that work. But I think there'll only be finitely many, right? Examples where A to the X is bigger than C times B to the Y. I think that's the case because it's my positive whole numbers. So there's this bound that A to the X will be smaller than 1. It's smaller than A. X is positive and whole number. C, B to the Y will be quite large. So, okay, in the case that there's this kind of band then between CB up to A. If A is bigger than CB, then there's this kind of band with interesting points in, interesting integer points, right? Where Y is one of these whole numbers, not too big, and A is one of these whole numbers down to CB up to A. CB up to A. X is one of these numbers before this gets too small, where you pick one of those numbers on the left, one of those numbers on the right, and it works out. We log both sides. That's a very good idea. Logging both sides sounds very clever. Does it actually help you? Yeah, probably. If you log both sides, I think it turns into a comparing straight lines kind of question, like we were talking about for 2009, where we have some straight lines that we want to be positive or negative. We wanted maybe there to be not infinitely many examples. Back in 2009, we wanted infinitely many. We wanted it to be true for all n. Here we want this to be true for just some x and y. Okay, I think the answer is D. I've managed to convince myself that in case D, the left-hand side is pretty controlled. It's not big very often, and the right-hand side is enormous. So, and it's the overlap then is pretty limited. There's only finitely many examples. I don't think the stuff I've said out loud is very convincing. But I'm gonna pick D. You definitely can log everything. You're fine. You're allowed to log. I'm not quite sure what base you're going to use. Probably A. So what are you going to do? Log base A. log base a of c plus log base a of b y. Oh, now I should have picked b, right, to make this look more like the equation of a line. Yeah, if I pick log base b, so I pick log base b, log base b of c plus y, this looks just like the equation of a line. So I want that gradient to be negative, so that this thing only has a few solutions. It's not generally true. And if that gradient's negative, that's because, yeah, that's the case if a is less than 1 and b is bigger than 1. We're taking the base of something smaller than 1. Sorry, we're taking the base. The bases are larger than 1 number, and a is smaller than 1. Cool, okay. Draw log graphs. 2 cases. Yeah, you should worry about whether log b is positive or negative. If you do this one, you could worry about whether this term is positive or negative. If you do it like this, you could worry about whether this term is positive or negative. I like those different approaches. I like that. I think I managed to give it to myself just by looking at powers. But yeah, logs is an interesting way too. The logarithms are fine for the inequalities. You're right to be nervous. But logarithm is it's an increasing function. So log of a large thing is larger than log of a small thing, provided that both things are positive. I mean, both sides are positive, so they're cool. But log is actually, it respects, you know, the magnitude of the number. Large input gives you a large output, and vice versa. Squaring is dangerous because squaring takes negative numbers and it returns large positive numbers, which is not respecting the inequality. Log base 1/2. Oh, I do have to worry about that, don't I? Is taking log base 1/2 like doing a negative thing? I think log base 1/2 is fine, isn't it? No, it's negative numbers, isn't it? Ah, bother. Okay. Yeah, maybe I do have to be a bit careful. Yep, okay. Worry. Log base 1/2 is a bit weird, isn't it? Yeah, I've drawn log base b of x. I think my picture is only the right picture if b is bigger than 1. Yeah, okay. Good, cool. Logarithms, be careful. Oh, this happened in the PAT live stream. Log with inequalities and logarithms with fractional bases less than 1. This gives me a really good homework problem for me to understand this better. So I've learned live on a stream that I'm not totally confident on what log base 1/2 x actually looks like. So my homework is to go to Desmos and play around with that. Because I'm a irresponsible kind of live streamer, I'm just going to do it live on here. Good. So I think the problem I was seeing was for when b is between, yeah, so I was drawing these ones, logarithm like that, but then the one I don't quite understand is log base 1/2. Desmos is showing it this way up. Does that make sense to me? Log base 1/2 of 2 is -1. Let's make that actually 1/2. Okay, log base 1/2 of 2 is -1. Log base 1/2 of 4 is -2. Log base 1/2 of 8 is -3. Because 1/2 to the -3 is 8, you've got to put a minus sign in there to make the power of 2 flip it up to an 8. Okay, so it's this one, it's decreasing function, which will flip your inequality. Because you put a large number in, you get a more negative number out. Cool, okay. Watch out for your logarithms. Oh, I like that, look at that, that's really good. That bends really smoothly. I've genuinely never done this before. Should have. I've now got a better mental image of what logarithm looks like for different bases. You can animate this, can't you? Okay, I'll just leave it going. Good, right, okay. Oh yeah, it's just negative log base 2 of x. Fair enough. Come on, Desmos, you can do it. You can do it, Desmos. Yes, there you go. Beautiful. What a nice relationship. Log base B and log base 1 over B. Good. Now I'm not trying to algebraically prove that, but I will actually do that as homework rather than on a live stream. There you go. We're understanding logarithms together. Right, we're going to look at question 2. We've got half an hour, which is a bit fast. We're going to look at question 2, and then we're going to pick out parts of question 3. In that order, I think. Here we go. Oh, okay, faster and faster. Yeah, you got it. So summary there for Herb. If you take a logarithm base number between 0 and 1, that's a decreasing function, so it flips your inequalities. Just like multiplying by -1 would flip your inequalities. And there's a request in chat for 5 as well. Okay, here's what we're going to do. I'm going to do 2 and 3, and then 5 if I've got time, and also if I don't have time. There you go. It's a bit of a weird day, so we can just do that sort of thing. Okay, squaring both sides of the equation, we're going to show that a equals b equals c equals 0. Oh my goodness, a, b, and c are integers. We're going to suspiciously show the suspicious of this expression. It's going to turn out to be 0 equals 0, and it tells us to square both sides. So if we do that, we get 2ab root 2. I've got to square it correctly, haven't I? 3c squared on the right. Oh, I see. Okay, so I've now got an expression for root 2. My suspicion with all these integers and root 2 around is always that I should try and write an expression for root 2, because I know that doesn't work, right? You can't write root 2 as a fraction, and here it is as a fraction. So contradiction. Unless a equals b. The way out of this contradiction is that, well, I divided by 2ab, which wouldn't be allowed if a is 0 or b is 0. So then I suppose the strict conclusion is that, one of these is 0, and then it follows quite quickly. Let's say, okay, so it's that thing where it's almost fallen apart. So it's this if 2ab is not 0, but that's nonsense, that's contradiction, because root 2 isn't rational, can't write it as a fraction. If 2ab is, so 2ab is 0 instead, which means that either a is 0 or b is 0, actually both, we're going to find out, but it means a is 0 or b is 0, or both. If a is 0, then b is equal to c root 3, and if b is 0, then a root 2 equals c root 3. Now either way, that's an expression pretty clearly for some irrational number to be a fraction. In this case, b over c is root 3. In that case, a over c is root 3 over 2, square root of 3 over 2. Those things are irrational, so something's gone wrong. So c is 0 as well. You're not allowed to divide by c either. That's the only way out. Once you've decided that, then both of these read. So on the left, b equals 0, and on the right, a root 2 is 0. So a is 0. So we end up with everything being 0 in either case. It's slightly fiddly. We do have to use all 3 of these facts, I think. So yeah, thanks for follow through. So I've written down b equals c root 3 rather than minus c root 3 because I've actually gone back to the equation and plugged in a equals 0 in here, rather than reading up here and plugging in a equals 0. I would always go back to the original equation rather than the one I was working with, because that avoids issues around squaring and introducing additional roots, which is what we've done. I can assume that root 2 over 3 is irrational. Someone in chat says I can only assume that root 2 over 3 is irrational, but I've been told that they're all irrational right here. I may assume that all of them are all irrational numbers. Okay, so irrational fun. I wouldn't blame you if you stopped here. I mean, not mathematically watertight, But if you stop here, then I think you've had the main idea that, oh no, this would let us write root 2 as a fraction. And you can't write root 2 as a fraction. There's a technical bit to finish it up, but you say, actually, no, all three of these things are 0 because you can't just get out of this by making one of the things 0. It actually all falls apart. Goodness me, right, okay, moving quickly. Part 2, suppose that mn, big M and big N are integers such as the distance from point. Oh my goodness, they're the same distance. So let's write down those distances. I'm not going to bother writing down the square roots. It's almost like we shouldn't have the square root in distance. No, that's a hot take. We should definitely have the square root in distance. But things are nicer if you don't write down the square roots. If you multiply this out, then you get some expression which has some root 2's in it, has some root 3's in it. We're going to use the first part. So there'll be some coefficient of root 2, some coefficient of root 3, and some leftover number. And we're going to say that all of those things have to be 0, because we showed in the first part that a bunch of these things are 0. Oh, sorry, I see what you're saying. Anonymous in chat is telling me that I can't assume that root 3 over 2 is rational. I can only assume that root 2 over 3 is rational, because that's the one in the question. Did you see me pause while I was doing this? It's because I divided the wrong way. I should have divided by A rather than divided by C if I wanted to use strictly the thing in the question. You're right. Of course, if one of these was rational, then the other one would be as well, because you could just flip the fraction over. So those facts are very related. But you're right, I should either use the fact in the question, or if I'm being really precise, prove the fact that root 3 over 2 is irrational. Cool, thanks for calling me out. That's good. If I'm going to go to the effort of being pedantic and doing all the extra steps, then I should at least do them correctly. Okay, so I think my plan is to multiply these things out and compare coefficients, because what we've really shown up here is that when you see something like this, you can look at the coefficient of root 2, the coefficient of root 3, and those are going to be 0 in order for this thing to work out, if everything's an integer. Okay, and I've got a bunch of integers in here, so I'm excited. This is going to work out really well. Oh my goodness, I've got so many terms. I've got an m squared and an n squared, which I've written first because they're numbers. I'm going to get a 2 and a 3 from multiplying out these, but I'm getting those on the other side as well. I suppose this right hand side is going to be the same, but with caps lock turned on. So that's good, I guess. Oh my goodness. I've decided not to write down +5 on both sides. Caps lock minus 2 root 2 caps lock. Cool. Okay, and it looks to me like there's a coefficient of root 2 hiding in there. The coefficient of root 2 is something to do with m take away big M, and the coefficient of root 3 is something to do with little n take away big N. So if you move everything onto the same side, if you maybe move all the root 3's on the right, that's a 3. If you move all the 3's onto the right and all the root 2's onto the left, then the coefficients A and C turn out to be exactly what you want in order to show that M is equal to big M and N is equal to big N. So if B over C is square root of 3, so Andrew's pointed back to this bit, root 3 is irrational. So technically what I'm supposed to do here is when you see B equals C root 3, then either B over C equals root 3 or C equals 0. Because either C is 0 and you're not allowed to divide by C, or if C is not 0, then you can divide and you'll get root 3 as some fraction. This one is not okay because root 3 is rational, and this one is where we're going. So we're going to say C is 0. So technically there's this like dichotomy, either this or that, and then I've ruled out one of them to say, aha, so it's the other case. I'm sometimes shortcutting that process, I suppose, that if there's two options and one of them's stupid, then I say, so it's the other one. I don't always spell that out. Maybe I should. What sort of maths is 1? This kind of proof of irrational numbers is proof that numbers are irrational is sort of its own thing. Not really sure which category I'd put it in. It's related to number theory, like prime numbers, I suppose. That's not a very helpful thing to say. It's like 3 little proof by contradictions. Maybe I phrase things too often in terms of proof by contradiction. Maybe I should just go for it a bit more. Okay. Comparing coefficients is maybe what I'd refer to it as. Checking that the field extension with root 2 and root 3 is never mind. Right, good. Okay. Less than or equal to r. So capital N of a, b, and r means look at the point AB and find me the points with integer coordinates such that the distance to AB is less than or equal to r. So in the picture, N of 1.2 naught, so this is a center 1.2 comma naught, that's AB, and r is 7, distance 7. Let's think with a radius 7. Doesn't look like 7, does it? Oh, sorry, 1.5 is the number 7, sorry. 1.5 is this radius. There we go. This is why you draw a picture. R is 1.5. That's the circle. Okay. AB and radius R. And there are 7 points inside here. 1, 2, 3, 4, 5, 6, 7. Good. Okay. That's fine. 7. This thing, if you center it on 0.5, 0.5. So if you center it on 0.5, 0.5. Then your circles will have rotational symmetry, so they will just cover these 4 points by sort of rotational symmetry by 90 degrees, about 1/2, 1/2. Means that for each point there's an image 90 degrees around, and again, which gives you a multiple of 4. That's the number of points. In chat, we're still talking about irrationality. Can you use the proof for root 2 to prove that all surds are irrational? Yeah, the same proof works. It's a little bit subtle. So this kind of standard proof that root 2 is irrational. You have to be careful when you generalize it, because root 4 is not irrational. And when you're talking about root 6, the number 6 is a little bit different from 2. Somewhere in that proof, the fact that 2 is prime is relevant. So it's not a game changer when you're talking about 6 instead of 2, but it's subtly different along the way. But you do the same sort of steps. The reasoning behind some of your steps is a little bit different. You have to be really careful not to prove that the square root of 4 is irrational. The square root of 4 is 2. That's not irrational. You can't just find and replace all the 2's with 4's. Otherwise it would be false. Yeah, okay, so this is hard to explain, isn't it? We're starting near the point 0.5, 0.5, and we're looking for points that are within a distance of r. And I'm claiming that they turn up in a multiple of 4 because of rotational symmetry. But that is a bit vague. Particularly, there's circles that look a bit like this. Oh, it's one of the greatest circles anybody's ever drawn. Which has got 12 points inside, arranged in this kind of plus sign. Let's try and show you that plus sign I'm looking at. And I guess it's a little bit awkward to talk about how I'm imagining these belonging to like these 3 points, and then the mirror image, the rotational image, and then the rotational image, and the rotational image. For each one of these, you can rotate around 90 degrees. I think that's the best way to talk about it. In terms of what happens when you rotate by 90 degrees, you find a new point that's also inside the circle, and it's not one you had before. You can do that. For each point, you can separate them up into these kind of groups of 4. Yeah, maybe I'd use the word, split them up into these collections of 4's. Sometimes a good way to prove that something's a multiple of 4 is to divide them all up into little groups. I would definitely do diagrams for this. I think a good diagram would convince a marker that you'd had the right idea about why it was true. You know, the mark scheme is going to say something like, look out for anyone who's had the idea of rotating or the idea of symmetry. and then if your diagram is pretty good. I don't have to talk about rotational symmetry actually, do I? I could talk about reflectional symmetry instead. Maybe people would prefer that. So for each point on the right of this line, x equals 1/2, there's another one on the left. And for each point above this line, there's another point below. I think the reflections might be easier to follow. So for any point that's inside, there are some points over here, up in this quadrant, above, and then there's mirror images in the other 3 quadrants. People are going to prefer that, aren't they? Will my drawing count as a good drawing? Not really, because I've just been scribbling on the one in the question. I would instead, once I've worked out what I'm going to draw, I would draw a new version with my axes, the point 1/2, 1/2. I've decided I'm going to talk about reflections, so I'm marking those 2 lines. I would put in some points over here to show that I'm doing this kind of general case. Let's say there are some points in the set x bigger than 1/2, y bigger than 1/2, that region. Also points in, and then I would name the other 3 regions by reflectional symmetry. Same number in each. So multiple of 4. Cool. I would lay it out a little bit like that, I think, and I would draw a slightly better diagram with just the key elements in. That's probably what I would write. Okay, and then k equals an integer. Explain why you can start at root 2, root 3. Oh, I kind of get it, I think. So distance from root 2, root 3 is what we were talking about in part 2. And what we actually showed in part 2 was that if these 2 integer coordinate points have the same distance, then actually they're the same point. So in part 2, we saw that no 2 distinct points have the same distance. They're the same distinct integer points. Same distance from root 2, root 3. So increase are from 0 upwards, and discover points 1 at a time until you have k. You don't go past k because you discover them 1 at a time, so you never miss out. Cool, right, okay. 10 minutes, and I promised that after question 2 and question 3 I would do question 5. So I think I'm going to salvage bits of question 3. Let's talk about what we're supposed to know and what we're not supposed to know. Here's a diagram. It's all about arc length and trigonometry. So the idea here is that this little bit of arc length, if you're using radians, the length of the arc is this thing on the right. The length of, oh sorry, it says areas. It's all about areas. The idea is that the area of the circle, section of a circle, is something to do with x. The area of this triangle is something to do with sine x. And then, oh my gosh, x cos x is something to do with the area, oh, there's a tan x in here. If you have a right angle, then this side is tan x. So the area of the larger triangle OAB is something to do with tan x, and it's bigger. So tan x is bigger than something to do with the circle. So there's a shape here which is like comparing the circle to the small triangle, gives you something like x versus sine x. Comparing the big triangle to the circle gives you something like tan x is bigger than something to do with x. I think there's a 1/2 in here as well. I can't remember where the factor of 1/2 comes from for the circle. Angle divided by 2 pi, it's just how areas work. Something like that. Good. Yeah, this fact is quite good. These expressions, by the way, that tan x is bigger than x for this range, and sine x is less than x. These are just quite good. They're quite handy. They're only true in radians, then not true in degrees. Then we're asked to sketch sine x over x. Justify your value y. Oh my goodness. The key here is that sine oscillates. 1 over x comes in towards 0. So this thing's going to oscillate, but also it's going to have roots when x is n times pi. But also it's going to, magnitude is going to come down. When x is really small is a very hard question. But I suppose we've now proved that this is somewhere between cos x is less than sine x over x is less than 1. Both of these things get really close to 1 when x is small, so this thing is going to get close to 1 when x is small. You do not need to find the coordinate turning points. Good news. Sketch on the same x as the line y equals cx, where c is such that this has exactly 5 solutions. Seems a bit unlikely. There's definitely a solution at 0 because cx definitely goes through 0. And so if I make my line really steep, then there's no solutions. But if I make it just come in like this, I'm going to pick up some extra solutions from here and here. So I've already got 3 solutions. And then if I make it just sort of touch the line curve over there, then I can get some solutions over here and over here. So I'll get 5 solutions like that. Okay. So drawing this line in so it just touches like that. Could I do the opposite? I could have a negative gradient, but it's told me that c is positive, so I want that one. Draw the line y equals c such that you get, so from my graph before, I want 5 solutions, so I'm going to get the x negative as well. So I suppose I add in x negative? This thing's, okay, so I'm going to have exactly double convolute there. I'll get my 0 solution. Why don't I have 0 solution anymore? I've multiplied that by x, it's fine. If x is larger than the 5 solutions, that's this one. So this is the point where sine x equals cx, explaining why tan x is equal to x. Oh my goodness. That'll be comparing the values and the derivatives, and then plug it back in. We've got its tangent. So plug it back in. Right, cool. What can we salvage from this question for the future? I don't think that differentiating sine and getting cosine is on the syllabus. I mean, I know it's not on the syllabus, so I don't think this is really kind of great at the end. I mean, you're told this fact, so if we're told this fact in the question, then that's fine. I think we should salvage the idea that the number of solutions you get can change depending on the value of a parameter. There's something in this, I think. So the number of solutions, whether or not we understand why there are some solutions or not to this. So what do I want to do in Desmos? Y equals cx with a slider for c. The number of solutions has some kind of special cases where, okay, so help me out, Desmos. Sometimes you've got to help Desmos get the right kind of range for your parameters. So it's kind of normal picture like this where it's got quite a lot of solutions, but then just off screen, has it got more solutions or no? It's just missed, so nothing else over there. So this is kind of working out that you could have some more solutions in a kind of special case as the line kind of stops crossing. A special case where it's tangent, and it's tangent not quite at the top. Oh, I've missed. It's tangent not quite at the top of the curve. It's tangent somewhere slightly to the left. There's some stuff to play with here, I think. So I think the thing we salvage is that this is kind of an interesting interaction. Sine x and cx. You could set Desmos to degrees if you wanted to, I suppose. How do you even do that? Oh, there it is. Degrees. Oh, that really ruins the picture. Right, good. Okay. So I think that's what we salvage from this question. How would I actually find c? Oh my goodness, I would not. C is, I think, something to do with the solutions to this equation. Yeah, C is the value of cosine x at the value of x such that tan x equals x. There's not a nice expression for what that number is. It's just a mess. So I would not find C. But I would draw it with its properties of being just sort of tangent. Which maybe gives us the idea of how to talk about these repeated roots. There's something going on there. Okay, I'm almost out of time, so if you've got to go, then I'll see you next week. I do want to talk about question 5, because there was a request in chat to talk about 5. I think it did all right in the vote as well. So I'm going to talk about it. If you don't want to see this now, then I'll see you next week. If you're going to watch the replay at double speed, then I'll see you in the replay at double speed. Let's try and talk about the date month stuff. I love this question because it's very accessible. It doesn't use any matter in the syllabus. It's just keeping track of repeated numbers. I used to say that I didn't like it because who cares about the date formats, right? But it's, I think, a very accessible question. Herb asks the hard question, what is the solution to tan x equals x? And bad news, doesn't have nice solutions. I mean, it's a number, right? Tan x goes up super fast, so tan x is going to be equal to x at some point, but it's not a very nice angle or anything like that. So yeah, in general, equations can have just awful solutions. Sorry. Right, okay. There's information in this question about the Gregorian calendar, which I sort of love. It has stuff about leap years. This is not relevant for the question, really. It's true, but you don't. I mean, it's true because it is what the Gregorian calendar is, so I guess they have to write all this, but luckily this question does not involve thinking about leap years. Oof. Right, okay. Show the no date with no repetition of digits, so kind of double negative. Any year in this range has a repetition of digits, and I can already kind of see that there's some repetition of digits inside these years, so it's definitely, if the year is 2000 or 2019, I can already see a repetition of digits, but I suppose it could be something like 2013, which didn't immediately have a repetition of digits. Here's the thing, any of those would have a digit, so we've used the digits 0 and 2 already in our year. We're not supposed to repeat any digits across the entire date if we're avoiding repeats, which means that I'm a little bit worried about D1, because D1 is the first digit of the day of the month. D1 I know is either 0, in general it's either 0, 1 or 2, or 3. So 1 or 3. And I'm a bit worried about M1 as well, because M1 is either 0 or 1, and we've already used the 0, so M1 is 1. And D1, okay, so M1 is 1, D1 is 3, and then what's D2? So thinking about D2, well, we're in the 30s in a month, and at this point I've used 0, 1, 2, and 3. So what is it? The 34th of June? No, it's nothing like that because there aren't enough days in a month. D2 is actually quite restrictive. If D1 is 3, then D2 can only be 0 or 1. So nonsense, doesn't work. Part 2 wants us to look at the past, so years before the year 2000, and explain your answer to look for no repetition of digits. So I guess our year is going to start 19 something something. I guess we'll start looking there, and if we have to go back to the 1800s, then we have to go back to the 1800s, but there we go. Chat's faster than me. Anonymous person says look at M2. M2 would have been a quicker way of doing that, because looking at M2, yeah, if M1 is 1, then we're in October, November, or December, and we already used 0, 1, or 2. That's quicker. I like that. Quick solution. The reason I'm happy about looking at the 1900s is that part 4 is how many such dates were there in the years. If it's none, then that's quite easy. We'll have already worked it out. I think part 4 really strongly hints that part 2 is somewhere in the 1900s. Right, what do I want then? So not the 1990s, because that repeats the digit 9. So maybe Y3 is 8. That'll be quite recent. in the 80s. Maybe Y4 could be 7. That would be the most recent. Try that first. And actually, you can make this work. So we're going to be okay. We're going to use small numbers like 2s and 3s and 0s for our days and months. What do we want? I suppose we want the month to be. Oh no, sorry, we want large numbers, don't we? Because we want the last date before today. So I can't make. Can I make the month? I've used 1, so I could make the month. I've used 9 as well, and 8 and 7. But I could make the month 06. It's important to me to get the year to be a big number because I want a more recent date. So the years. The years make it more recent than messing around with the months. Ever could help. I'm not being very clear there. Years are more important when you're deciding what time it is. If you get out of your time machine, and you want to know when it is, the first question you should ask is what year it is, not what month it is. Years are more important. Okay, we've gone back in time to a date with no repetition of digits, so we should think about the year first. Try that first. The month 06 works, and then I guess I want the day to be massive, but I've used at this point, so I can't make the days. Day is not. I can't make the day 31 or 30 because I've already used 1. Oh, I haven't used. Oh no, I've used 0 now. And I can't do 29 because I've used the 9. I've realised that June only has 30 days, so I couldn't do 31 anyway. A bit of a mess. I can't use 8 or 7 or 6, but I could do 25. So 25, 06, 1987. There you go. It's not too bad. Not too bad. Yeah, I like that. Cool. We do a Doctor Who reference 2 years in a row. How many marks just for writing 25th of June 1987? I think 1 at most. So maybe 1 because come on, you got the mark you did to get it correct, and it isn't written in the question, so you aren't just you've done something. But then loads of marks are going to be for explain your answer. Let's check the mark scheme for what this question was worth. This question was marked out of 2 marks for the first part, 3 marks for the second part, 6 marks for this part for the next day. Ooh, 4 marks for this last part. Okay, next such date. So we're going to go to the future. We've already looked at years up to 2099 in the previous part. So it's very tempting to write down 20 question mark, but we already did this. We're going to go to the year 21 something. And I suppose the smallest number we could put down here would be 2103. But if I go to 2103, then I've really run out of small numbers to use for months, haven't I? I've got to leave myself a small number for a month. So I think I'm supposed to go to 2104 next. I just worried I'm not leaving enough days left over for the month and day. Yeah, so I should think about the months again. If I'm starting in the 2000s, writing the answer is necessary but not sufficient, there calls on it. 23rd of June. Good, okay. Oh, there was a time machine. That was the Doctor Who reference, I guess. What year is it? Not what month is it? Maybe that's Doctor Who reference. Maybe it's just a time machine. Okay, so there's a 2 in here. So M1 is either 1 or 0. Which means I shouldn't use both in my year. And then can I talk about D1? So D1 is breaking down a bit on my systematic approach. So M1, Y1, Y2 and D1 is the way in, I think, to look at the the years that they're going to work. I'm worried that the ones and zeros are getting stretched quite thin across some of these other parameters. Yeah, so I think I want to talk about D1 next. So D1 could be 3. If it's not 3, then it's not 2, so it's 1 or 0. And then I'm a bit stuck. No, I'm not stuck. Just not stuck so much as. Yeah, if D1 is 3, then D2 is 1 or 0. So either way, the day involves a 1 or a 0, and the month involves a 1 or a 0 as well. So I can't use 1 or 0. So either way, 1, 0 used in D1, D2, M1, M2. So I can't use 1 or 0. I've got to go to the next numbers. Which if I ban those numbers, the next year is 2, 3, 4, 5. And then I've got to put my date and month in. This time I want to pick small numbers so that I'm not too far in the future. I guess I'm going to put 0 here. Can I use January? No, because I need a 1 or a 0 for D1 or D2. So I've got to use the next number that's available, which is 6. And then over here, I'm going to use my 1 as the first date of this bit, and then I haven't used a 7 yet, which is the next smallest available number. So I think 17th of June, 2345. That's my answer for that part, which is decent distance into the future. Okay, so there's this key fact then that you can look at the D1 and the M1 and the D2. There's this kind of thing that D1 could be 3, but then D2 is very restricted, and M1 is pretty restricted anyway between them. Right. Wouldn't 6th of January be sooner? 0601 involves 2 zeros, Nick. Yeah, good. Okay, I am doing this as fast as I can because we're past 7 o'clock. Started early, finished late. That's timekeeping. How do you find timekeeping less stressful? Just do loads of times. No need to apologise, Nick. Stuck the 01 in, and then the thing about I considered an 01 as well. Very near the end, I considered an 01 for January because I hadn't used those numbers yet. But then that really does ruin your D1, D2 for all possible D1, D2s. There's no dates in January because I was still thinking a little bit about how D1, D2 has to use a 0 or a 1 in some order. Cool. Right. Let's think about part 4, which is the 1900s. Put the question at the top of the screen, so you get plenty of space down here for part 4. This is not a tidy solution, by the way. I did a lot of talking out loud and not writing. I should do in an exam more writing. Good thing we haven't thought about leap years yet. Yeah, I don't think we will. 1900s doesn't really help us at all because it's the ones divisible by 100 and the ones divisible by 400 have 2 zeros in them, so they're not going to be in our counting. Okay, what have we got? So we've got 19 something something. We've got days and we've got months. So I want to look at zeros and ones and D1s and M1s again. I suppose M1 has to be 0 in this case because the months only go up to 12. So there's going to be a 0 in here. And now we've used 0 and 1. So D1 could be 2 or 3. Yeah, I think that's true. I think D1 could be 2 or 3. Oh no, if it's 3, then it would be 30 or 31. So D1 is 2. Cool. I should not go back and write it in, right? But, you know. And then I think we're good. Because that question mark could be anything, the second question mark could be anything, and the other ones could be anything. So we've got to pick some numbers to put in there. But at 20 something of the 0 somethingth month in the year 1900 and something, those all don't have any repeats, provided the question marks don't have a repeat. So this is now combinatorics. Now, if we follow this template, then we get ones. This is necessary and sufficient. The dream. Sufficient, because if you start filling in the question marks without repeating things, then you're good. No repeats. And necessary, because we've checked the other cases, and the other cases don't work. M1 has to be 0 because it's not 1, and D2 then has to be 2 because it's not 3, and not 0 or 1. Those are the ones with the most restriction already, and if the year starts with a 1, then there's extra restriction, which means that actually this is fine. We just need to pick 4 things to write in there out of the remaining 6 digits. 6 digits, and we've got to write down 4 of them. So we've got 6 choices for the first thing that we write down, and then 5 choices, and then 4 choices, and then 3 choices. The order matters, so no need to do any fancy dividing or something. 6p4, 6 permute 4 if you use that sort of notation. Some people write it like that. And the only thing I need to do is multiply, and then I can go home. It's 6 factorial divided by 2, which is 360, right? Yeah. Why do I know 6 factorial but I can't multiply? That's not right. That's not correct. 6 factorial is 720. Divided by 2, 360. Okay, we got there. I don't think I've done the last part of this question before. I've definitely seen this question before, and I've messed around with the previous parts. I don't think I've ever done the last part. The last part's a lot easier than I thought it would be. Because once you've got the restricted bits, the kind of flexibility is there. Oh well, okay. Cool. You did it. Combinatorics questions, any particular topic. Combinatorics is the sort of thing that comes up in lots of other maths competitions and tests and fun things, because it doesn't use very much A-level maths or GCSE maths. These kind of counting arguments. There's only a few ideas at this level of how you might count the things. The kind of overcount and then divide method that you've seen. If you've seen 6 choose 3, there's this kind of overcount and divide method. And just comparing the set to something else you recognise and counting that instead is the other trick that I know. They're good questions in general, combinatorics questions, for people who like math competitions and things, because they give you a lot of scope to have a clever idea and do something clever. I know that makes them really hard because you have to have a clever idea, especially if you're doing the sort where you're counting some objects and you have to realise that they're equivalent to different objects that you can count more easily. Maybe you're counting tours and you realise that a tour is just a sequence of letters and the letters have some restriction on them, but then you can count the sequence of letters. Not actually that problem, because that problem's hard, but that sort of thing. Good. I've missed a train, but it's fine. I can get another train, provided they send me another one. That's the plan. We run late, we get a different train. Good. Is there anything else I want to talk about? I've got 15 minutes, probably, before I start missing extra trains. I think this kind of recursion, by the way, is worth having a look at. Whoever you are. I know it says for applicants in computer science only. We saw some computer science applicants in chat earlier. Hey, there's this condition here, and this kind of relationship, and it's described as a sequence of moves. So there's this kind of a relationship that I was just talking about, where you have some counting to do with these objects, which are games played by cats and mice, but then we translate those into a sequence of moves and we count those instead. We get some rules for how you might count those these kind of relationships for sequences rather than relationships on the games. The kind of translation translates it into a form where we can do some counting. Turns out to be vaguely familiar sequence of numbers. Maybe not the most familiar sequence of numbers, but it's some numbers I've seen before. So practicing 5, 6 and 7, resources that I'd like to recommend at the CS website. So to find this, I've searched for cs.ox.ac.uk and navigated their website a bit. They've got some suggestions on how to prepare, including the standard ones that I also recommend. They have some Dr. Frost links. They also have a link to the thing you're currently watching, hooray! Which I think passes the buck back to me, Oh look, AMSP. Is that the working link? Oh yeah, look. Oh, cool. AMSP. They often involve thinking quite logically. Getting some experience of being stuck on problems that involve this kind of breaking down your problem into smaller pieces. Lots of programming challenges work like that. So if you've got access to some sort of like Project Euler sort of programming challenges or BebRAS or something, these problems where you take a big problem and you try and break it down into a slightly smaller problem, that's the essence of recursion. That works well for a lot of things that look like question 7 here. The truth and lie stuff, I don't know how you get better at it other than meeting a bunch of truth and lie problems or just thinking really clearly, writing down what you're thinking, trying to come up with your own notation of keeping track of what your thoughts are. And this kind of stuff is just, this feels like trial and error, right? But it's quite systematic trial and error, where we're making sure we check all of the cases. If you check all of the cases, it's not trial and error, it's just proof by exhaustion, which is very much allowed. I saw someone in chat ask earlier whether trial and error is allowed, and it is, provided you try everything, which is the kind of worst thing you can hear if you wanted to do trial by proof, trial and error. Yeah, it does turn up Catalan numbers. Is that spoilers? You see the number 42, and at some point in your life you see the number 42 and you think, it's the number from the Douglas Adams book. And then later on, when you've seen some counting problems, you see the number 42 and you think, it's the Catalan numbers. It's just definitely going to be the Catalan numbers, right? 42 is one of the Catalan numbers, which is, you know, that's I shouldn't say spidey sense, but because I'll get sued by Marvel. But that's my impression. I think it's going to turn out to be the Catalan numbers. Should we have a go? GHM. So this is a table with H and M in, and you're supposed to work out it's H of M plus 1. Where's that? So this is HM, and H of H comma M plus 1 is this thing, and H minus 1. No, HM is the one above. HM is the one above. That's H M plus 1. And H minus 1, M minus 1. M minus 1 is, oh my goodness, where's that? Down here. Oh, weird relationship. Supposed to add like this? That's weird. And M is bigger than 1. Because we already knew that G of, so we knew some values up here. H comma H minus 1. So when M is equal to H minus 1, which is this diagonal, it's H minus 1. Okay, so we filled in those numbers. G of H comma 2. H comma 2 is equal to G of H minus H1 for H bigger than 3. What's this? Oh, I'd like that. I would like H comma 1 as well. Is that part of the question? No. Cool, okay. I haven't read about the cat and the mouse, so I'm not going to be able to fill in this table. But I've just got a feeling it's going to turn out to be the Catalan numbers, you know. Here's a 5. Is that enough? 5 and 4 is 9. 9 and 5 is 14. That just feels quite Catalan flavoured. I'm going to have to think about what this number is now, aren't I? H is 4 and M is 1. Seems like, I just want to understand M equals 1, I think. I'm not reading all of this. Cool. It's sad that we won't see either of the dates in question 5. That is sad. One of them is just too far in the future. I don't know. Maybe you guys will live to be 300. I guess maybe YouTube will live to be 300. If you're watching this video in the year 2345, let us know in the comments. That's a long play. That's assuming that people in the future are watching 2.5 videos from 300 years before. They've probably got something better to do. If you show that the statement X is true, question. If you get a show that statement X is true, doesn't matter which way you argue, starting at X or ending at X. Yeah, you should end at X, I think. Technically, if the steps that you're taking are reversible, then it doesn't matter. But you should be a bit careful. So if you're asked to show that two numbers are equal, and your guess is to square both of them and check that you've got the same number. You square both of them, you get 9. That's not actually a proof that they were equal, because they might have been 3 and minus 3. I mean, they're not. We are proving that they're equal, but you've got to consider, maybe, what would happen if these things were not equal. So I would end with the statement X. JC wants to know if I'll still have this job in the year 2345. So there's this thing called the pension age in the UK, where at a certain point I'm allowed to retire. And the thing about the pension age is that they increase it sometimes. So I don't know when I get to retire because they keep putting it up. I don't think I'm going to be working in 2345, but if I am, I'll leave a comment. There we go. What a deal. This truth lie question, by the way, is extremely complicated. The people are talking about, look, either the people to my left and right are both lying or both telling the truth. Everyone says it. So here's a multiple of 3. That's just like, oh my goodness, what? Some of them always lie, is the thing. And there's like acceptable patterns of saints and liars, and the acceptable patterns all have length multiples of 3. This is really, really weird. Good, okay. Many of the colleges around in the year 1987. Yeah, a couple of them. So there's been teaching, the fact that we try to do is that there's been teaching recorded happening in Oxford since the year 1100, roughly. Although when I say teaching recorded, I don't mean that they put it on YouTube. We've got a little bit better about recording our teaching since the year 1100. We now record it live for you to watch at double speed. I think I'm going to stop talking in a minute. I'm definitely running out of things to say. YouTube tells me there are still people here, which is, to be honest, surprising. I think we did some of this work. Yeah, we did this question 4 on a live stream at some point. It's just loads of work, especially finding this triangle area at the bottom. Good thing they told us this fact about the triangle area. But it was a mess. What else have we skipped? We did that one on a live stream. We did a lot of Alice Bob Charlie lying stuff on a live stream. MXW stuff we did on a live stream. We've covered a lot of bases here. We've covered a lot of good questions. Nick wants interview tips. Nick, interview questions are a bit like MAT questions, but you only get to see part of it at a time. So in an interview, I might ask someone something a bit like this first part of this MAT question, and we'll do it together. And that's good because if I want the person to go through the kind of fiddly details, I can get them to do it live. And I can see how they're talking about it, and maybe I can skip forwards a bit once I've seen that they're being careful about those cases. Whereas on the MAT question, if you don't write down the fiddly details, then maybe you just forgot to, or maybe you just didn't think it was important. So the interview question can do a maths question, but where I get to follow up and I get to say, actually, I do want to see the details on this bit, or maybe I say, let's not actually do that integral. Anonymous wants to know, is that fact about the cross product? And Anonymous, you'll be excited by 2 or 3 extension questions on the live stream a while ago. You can think about it in terms of matrix determinants, you can think about it in terms of cross products, and you can think about it in terms of, oh gosh, there's another one, the shoelace rule, but nobody knows the shoelace rule. Nick, so Nick, you're already doing the right thing. You're doing maths questions. You might like to practice talking out loud about the maths that you're about to do, which helps you formulate having a plan in the first place. If you're talking to yourself about what your plan is, it's just good kind of awareness to have, right? Like if you say confidently to yourself, I'm going to integrate this, you can go and integrate it. It's good for the interviewers because then they know that you're trying to integrate it. You should not be penalised for bad arithmetic. If I did a 4-hour live stream, I've considered a lot of stupid ideas. One of the considerations was, how long could I do this before I have to go? Yeah, so extension question, I'm passing reference to extension question. If you go back through the worksheets for the live stream back to either trigonometry or geometry, one of those, there was a throwaway comment at the end there about on one of them. Let's see if I can find it about the cross product. I can't find it anymore. I found it now. Oh yeah, I had another rule using trapeziums. Cool. So the geometry sheet, had this question on, and then as an extension, if you've learned about the area of a trapezium, drop perpendiculars, find this and deduce the fact about triangles, triangle area in the question. If you've learned about the cross product, explain the fact. So if you've already told me, because you came into this by saying that's the cross product, so you already have thought about it this way, but you might like to think about trapezia as well. And that question could also say several other things about if you've learned about X, explain this in terms of X. Personal statements, you're going to tell us that you like maths, you're going to tell us that you're doing bits and pieces of maths outside the classroom just for fun and to practice, and we're going to get you to do a maths test as well as writing a personal statement. So if from Oxford's point of view, you're going to do some actual maths for us, as well as writing your personal statement. If there's other stuff you think we should know, you could put it in your personal statement. It's up to you, it's personal. You can tell us about your personal preparation for university. Tutors for maths do not often ask follow-up questions about personal statements in the interviews because we've got some maths to do and I want to get on with doing the maths. So it'd be unusual for a kind of, definitely for me, it'd be unusual for me to do a discussion about somebody's personal statement or to dig into, if they've talked about prime numbers, to actually ask them about prime numbers, because I wanted to ask them about days of the year and doing my interview question, which I'm very excited and I'm ready to do my interview question. I think I said earlier, and I'll say it again, I've never asked someone about their personal statement in an interview. I think that's true. Sorry, if you're out there, if you've been asked a personal statement question by me in an interview, then I'm really sorry. Broadly the same for CS. CS have also got a plan to ask you some relatively mathsy questions. You should imagine it being as kind of maths experience. I'll set you up well, I think. I don't know how much computer science interviews might want to talk about your previous experiences. Possibly. It would make sense to me, at least, if they wanted to talk about what you're up to, how you know that you're interested in computer science, but maybe not. Maybe they just assume that you're interested in computer science because you're applying for computer science at university. We do 25-minute interviews, which is quite short compared to an hour-long interview, but quite long compared to a 10-minute interview. I don't really know. There are some resources for past interview questions. There's going to be a live stream on this channel, JC. So bonus live stream after the MAT. I keep doing this show. It goes fortnightly for a little bit. Every 2 weeks we do a bonus episode. One of them is going to be interview questions I've used in the past. If you're very keen, you can find last year's version of that bonus stream on this YouTube channel. And you can also find, in that one we'll link to other stuff as well for other examples of interview questions. But right now, let's imagine it as being a bit like that. Cool, right, I really need to go, so I am going to call it there. Thanks very much for joining in with the Oxford MAT livestream. If you missed the pre-live thing, I'm currently promoting a thing I did on the main channel. They let me on the main channel. I've been on the main channel showing people cubes. If you want to see what I did with cubes, it's about a minute of video. They only let me on the main channel for a minute. I would like people to see that, and I don't really understand YouTube. So if you could make that happen, I think it'd be really funny if everyone left a comment. Maybe I should give you like something stupid to put in the comments that's all the same for Oxford Online Maths people. It's a bit late now, isn't it? Cool. I've heard it's doing well on Instagram, which I don't have. So, you know. Have a good week, everyone. I'll see you in 165 and a half hours for another episode of the Oxford MAT livestream. Bye.